Hey everyone, welcome to the second Azure Cosmos DB conference. Azure Cosmos DB conference is an online event comprised of three-hour live streams across Americas, Asia Pacific, and EMEA regions, as well as an entire track of sessions available now on demand. Azure Cosmos DB conference was organized to provide a stage for Cosmos DB customers, developers, and community to share their knowledge and discover each other. Each of the regional live stream coming up includes unique content created by local members of the Azure Cosmos DB community. I'm Shweta Nayak, and I have here with my colleague Saji, and we are the hosts of the APAC segment of this conference today.
Hi everyone, I'm Saji. I'm very excited to listen to the wonderful session lined up for today. Before we get started, a couple of housekeeping announcements. Viewers who are watching this via Microsoft Learn TV will be able to ask questions in our moderated forum. Over the next 3 hours, you can see and hear from customers and community members who have built amazing applications and services. They are here today with us to show you what they have built and the things they have learned while building on Cosmos DB and for the cloud. If you miss any of the live sessions, no need to worry. These sessions will be available on demand shortly after each stream concludes. In a flash, we are going to start our first session. Over to you, Sweta, to introduce our first speaker.
Right. So our first session today is about serving customer data with Cosmos DB. It is going to be presented by Heber. And Heber is the data analytics manager at Grab.
Heber is going to give us a brief overview of how Grab is using Azure Cosmos DB to empower the Customer 360 API, which is an internal API that serves millions of consumer-centric data points to various systems in Grab on a daily basis to provide better user personalization. Let's welcome our first speaker of the APAC session. Heber, stage is yours.
Thank you. A very good morning, ladies and gentlemen. Welcome to this presentation. My name is Heber, a data analytics manager leading part of the analytics data product team in Grab. Today, I will be talking about how we leverage Azure Cosmos DB to serve individual customers' data to our services. Before we begin on the main topic, perhaps I can give a little introduction about Grab, who we are, and what we do. Grab is a Southeast Asian tech company, a leading super app in the region. Since its inception in 2012, it has grown rapidly, and today it offers mobility, deliveries, financial services across 8 countries in the region and over 400 cities. We also provide income opportunities for our drivers and merchant partners, and we aim to empower 1 in every 2 daily entrepreneurs in the near future. Now, as you can imagine, having this many users on the app naturally generates a lot of transactional data. And given that Grab has multiple business verticals, it is critical to consolidate these transactions into a per consumer level. This is so that we can have a holistic view of individual users' behavior. And this is where C360 project comes in. The goal of C360 project is to consolidate all our application users' data, including consumers, drivers, merchants, into individual user level in order to provide that holistic view of the user across all of Grab's business verticals. Its main product offering is internal data store, where individual consumer data points are aggregated daily using inputs from transactions and in-app behavioral data. To date, it offers thousands of data points with a coverage of over millions of users in our ecosystem. It is the single source of truth in Grab when it comes to user level data. Having this data store provides a critical avenue for us to do all the fun analytic stuff that you usually do with customer data, such as checking in on their life cycle, doing churn prediction, segmentation for marketing, and so on. However, as the usage of the data store grows, our teams in Grab begin to look into using this data store to do personalization or real-time prediction. And this requires a very different mechanism for retrieving single rows of data from the data store on demand. All the analytical workload that was mentioned previously are what we consider offline use cases and are not really time sensitive. But to provide data points to the online use cases, we clearly need an API infrastructure that we can retrieve individual customer data on demand. So this is where the C360 API comes in. We created a series of API endpoints in order to retrieve data of consumers, drivers, and merchants using Azure API management and function app services. For the backend database, we have chosen to use Cosmos DB. Why Cosmos DB, you might ask? Why not use something like, say, MySQL? Well, there are several factors that we considered when choosing the backend technology stack. And Cosmos DB has certain features that makes it appealing as the choice of database for our use case. The first reason for choosing Cosmos DB is that it is a NoSQL database. Here, data are stored as documents, with each document representing a single row in a traditional relational database table. A group of documents are stored in containers, which is the equivalent of tables in a relational database. A single document is usually represented as a JSON object, as you see on screen, where the internal fields of the objects can be loosely structured. Whereas in a relational database, it requires well-defined schemas that are inflexible to change. The properties of a JSON object document in a document database can be easily added, updated, or removed. Why is that important to us? Well, you see, in the case of C360, although we do have many attributes, not all of them require on-demand access via API. In fact, only a handful of those attributes are actively being used. However, we do run many pilot projects, and this often need on-demand access for certain attributes for a period of time. While the pilot project is running, those attributes needs to be onboarded onto the Cosmos DB, and when the project ends, they will be removed to save costs. This creates frequent changes to the schema of the document, for which in a relational database can be difficult to handle. Meanwhile, Cosmos DB with its NoSQL format provides the flexibility that we need in order to cater for this kind of use cases. That said, being a NoSQL database is only secondary to the next reason why we choose Cosmos DB, which is its incredibly fast point read performance. Remember that our API needs to return individual consumers' data point. This is akin to like reading a single row in a relational database. Now, in a relational database, in order to achieve the optimal query performance, you need to do some kind of horizontal partitioning and probably indexing on key columns just to scratch the surface in order to quickly find the rows that you need. However, this still requires the database to engage its query engine in order to retrieve the data. Cosmos DB, on the other hand, provides the mechanism called point read. When using point read to query a document by its ID, this query bypasses the query engine of Cosmos DB and talks directly to the storage layer. This makes the retrieval of a single document blazingly fast. And here's a snapshot of the performance matrix that we have retrieved using logs from our instances. As you can see, our daily calls amount to over 50 million per day, but the average time to retrieve data from the Cosmos DB is just under 5 milliseconds. Here's a breakdown of the operation duration for requests coming in through the C360 API. Here you can see the distribution of time taken for Cosmos DB to retrieve data, and it is usually in the single-digit milliseconds, which is incredible, given that we do have a lot of data. In fact, if you look at the P95 latency, it comes just a bit around of 5.5 milliseconds. And well, speaking of a lot of data, Cosmos DB is one of the most scalable databases in the current market. As aforementioned, the C360 data store contains the data point for millions of users. Each of these users translate to a row in a relational database or a document in Cosmos DB. So as you can imagine, the volume of data we have is huge. Even with very aggressive cutting of not in use attributes in total, the data can take up to more than a TB. Given that these data points are refreshed daily, writing in the new data into the Cosmos DB is a task that demands large amount of computational power. And this increase in computational power is on top of the normal capacity which we provisioned in order to serve the existing data. However, because this spike in demand of computational power is transitionary, the database needs to provide temporary additional resources only for ingestion. In a normal DB or DB cluster, the operation to increase this throughput may take up to several hours. However, for Cosmos DB, thanks to its auto-scaling containers, this operation can be done in less than 10 minutes or so. So now, having showcased some of Cosmos DB's strengths, it is not without some downsides. The biggest one being that Cosmos DB does not have segregation between its read and write traffic provisions. Now, both read and write traffic of the Cosmos DB shares the same amount of throughput that is being provisioned. So when one side of the traffic gets high, it will eat into the bandwidth of the other, where the other can operate it. This caused us quite a bit of trouble initially, since our daily updates writes a large amount of data into the container, and that blocks the read traffic from the Cosmos DB. Since our services run online 24/7, it creates an issue where the dependent services on our API cannot reliably retrieve data from the API during those daily data ingestion periods. To resolve this issue, we actually implemented a rotating container strategy. Each day, the updated data is loaded into a new container, while the existing containers continues to serve read requests. Once the data loading is complete, we switch the API to read from the new container. The old container is then deleted. This rotating container strategy ensures that data retrieval will not be disrupted by the high traffic of data loading. So leveraging on all these strengths of Cosmos DB, we have created the C360 API as a serving platform for our user level attributes. Currently, there are several production use cases that are accessing these attributes via the API. And I'm going to showcase two of them here. One of such use case is to feed user level attributes to our data science models for fraudulent transaction detection. Here, data points are retrieved by our data science model using a transaction whenever a transaction occurs on the application, and it will classify if the transaction is possibly fraudulent. We do have a very high daily transaction numbers, and as such, having a low latency API for this user level attribute retrieval is critical, since we do need additional buffer time for the predictive models to run. And overall, we want to compress that response time of between the user making a transaction to retrieving data from the data store and having the prediction model run to under 500 milliseconds. Here is where the speed of Cosmos DB point rate really comes into play, as we are able to serve large amount of requests that are coming in at an average latency of around 50 milliseconds round trip. This creates that buffer time for our predictive model to run, and it allows for a more complex model to run, which takes up more time, which usually ranges to around a few hundred milliseconds or so. And that is critical, for providing the kind of smooth user experience that we want for our app. Another use case is to provide differentiated customer service for different user segments. Here, user segments are predetermined by an offline data science model, and the results are loaded into the C360 data store as an attribute. This attribute is then loaded onto the Cosmos DB API for serving. Whenever a user contacts our customer service agents, our agents will first check through the customer service terminal, which will query our API in order to retrieve the user's segment. This user segment will indicate the user's classification, and we use that to identify high-value customers for priority services. So, in conclusion, Cosmos DB has been fulfilling the needs of serving individual user-level data retrieval exceptionally. Its no SQL format, fast point read performance, and rapidly scaling capacities has allowed us to create a system to serve such data reliably and efficiently. In our future roadmap, we plan to expand on the capacity of C360 API by optimizing the other parts of the system, such as the function app API endpoint code, and also the network configuration connecting the API management and the function app instances in order to reduce latency further. Additionally, we do hope to look into optimizing the daily data loading jobs, and we do that by optimizing the data pipelines that are currently running on Databricks. I hope this talk has given you some insights as to how Cosmos DB has been useful in serving customer level data. Thank you for coming to this talk. And before we end the session, perhaps we can take some questions from the audience.
Thanks so much, Heber. That was really great. We do not have any questions right now. Yeah, go ahead, Saji.
I noticed that you have built it using Azure Functions, API Management, and Cosmos DB, and you mentioned you're handling millions of requests across 20 instances, so with some of the container rotating strategies. So what are the best DevOps practices that you follow in terms of monitoring and troubleshooting?
In terms of monitoring and troubleshooting, I think the best DevOps we do use, so essentially our entire development ecosystem lives on Azure. On the DevOps side of things, we leverage on the Azure DevOps instances, which provides the feature called pipelines in order to deploy code reliably onto the function app themselves. And it provides the standard suite of CI/CD features that you will find on the other GitLab or GitHub websites. So that is very easily transferable. And so for data pipeline wise, we also do CI/CD for the data pipelines. We have a staging instance of the data pipelines, a staging Cosmos DB container, where we test out whether the data pipeline works when it comes to data ingestion. And the staging Cosmos DB instance do connect to a staging instance of the API endpoints, where users can test out and access the full range of attributes that we have. It is only when the users have tested out their use case on our staging APIs, that's when they can submit a request to us to say like, hey, we would like to access this attribute that you have on the production API endpoint. And that is when on the back end, we switch that attribute on the production API endpoint. And on the next day, that attribute will be uploaded to the production Cosmos DB data store. So having this very clear segregation ensures that our end users have some place to test out whatever they are using before they actually goes into use it in the production environment.
Got it. Thanks for sharing that insight. Yeah.
And I assume these are, like you said, and I know that Grab also operates across multiple industries. So your consumers are essentially these other teams within Grab, who I assume are from retail, transportation, different teams. Is that right?
Yeah, that's right. Our consumers are all the internal teams that are developing product features on the app.
Awesome. So do you have to, we provide like 5 nines of SLA in Cosmos DB, and how do you provide an internal SLA, commit to an internal SLA for your users? How does that work, and how are you able to achieve that?
Oh, well, in terms of internal SLA, we mark it by the round trip latency on Azure and
Hmm.
also the error rate. For round trip latency, we promise that it will be lesser than 150 milliseconds. And in terms of error rate, it will be 4 nines, 99.99% uptime.
Hmm.
So,
Awesome.
so far, we were able to do so uh, using a pretty lean team. It's also partly thanks to the stability of Cosmos DB itself. We have not encountered any major issues whereby there's an outrage on the containers or the service. Uh, and overall, the experience has been pretty smooth in terms of using the service.
Awesome. Do you use single region, multiple regions?
Uh, yeah, we only use a single region on the Southeast Asian region,
Hmm.
and that is basically where all our businesses are concentrated on. So having that uh, instance on in the region itself is also part of the reason why we were able to achieve this kind of low latency performance.
Right. Yeah. Makes sense. And yeah, approximately, I would say, how many requests per second does your workload operate at? And I mean, what's the scale of traffic that you're able to achieve with your databases?
Uh, well, at the highest point, it can handle a couple thousand. It has handled a couple thousand requests per second, and
Hmm.
we are not seeing any strains on the database so far. So we believe that there's still room for it to handle more requests per second. We do hope to achieve an eventual point whereby it can handle 20,000 requests per second. But that is barring that we resolve some bottlenecks on the networking between the different cloud components themselves. So this is currently one of our projects in uh, progress. Perhaps next year when we have a different we have the next Cosmos DB Conf, we will be able to share with you how we actually optimize the performance of this API.
I have one more last question before we
Mm.
wind up. Like you mentioned that you are using Cosmos DB heavily, like, and you mentioned some of the use cases. Since Cosmos DB is a multimodal database, what are the APIs that you currently use?
Sorry, I didn't quite get the question. Could you repeat it again?
Are you using only the SQL API, Mongo API, or
We are only using the SQL API.
okay, got it,
Yeah,
got it.
the use case is pretty straightforward, and so SQL API was sufficient for whatever that we need.
Okay, yeah, I think that's all we had on the question side.
Well, thank you very much for giving me this time to do my presentation. I hope you have enjoyed it. And yeah, I think that
Thanks.
will be all from my side.
Thanks so much, Heber. That was awesome. I do know that C360 is one of the most common use cases for Cosmos DB, and it is something that is used across multiple industries, retail, transportation, finance. And it was great to hear from Heber around how they have implemented the data pipelines and are benefiting from their customer 360 solution.
Indeed, Sweta. I'm sure there are other companies that need similar customer insights for improving their products and services that will certainly benefit from this session. Thanks again for your time, Hiba, and it was great to have you here today. Time to jump into the second session. This time we have an interesting topic from an interesting speaker. Yes, our next presenter is David O'Brien. He's going to present on the topic startup infrastructure, how to make scaling its sales, not a tech issue. David is the founder of Argus Security. It is a startup that helps the customers by finding, investigating, and fixing cloud vulnerabilities.
That's right. David will be demonstrating how they have leveraged the Azure PaaS services like Azure Functions and especially Cosmos DB to build a SaaS product that scales effortlessly already, and it's already handling millions of requests. He will walk us through how simple it was for him to build the foundations for their product and why they chose Cosmos DB for it and not any other database. Great to have you here, David. Over to you.
Hi, everybody. Welcome to my office / shoe closet / baby room. So everybody working from home probably knows what I'm feeling. Great to be here. And let's jump right in. Good. So startups infrastructure. Today I'm here to tell you a bit about how we build Argus, a cloud security product. I'm not going to spend too much time about talking about the product itself. It's not a sales pitch here, but really want to tell you from day zero, from day dot, what decisions did we make to make sure that we, once we hit commercial success, pretty much, or once we hit our X customer, that our infrastructure wouldn't hold us back. So we really wanted to make sure that sales could run as fast as possible, as fast as they needed to, and we wouldn't fall into this trap of, oh crap, on Monday, that huge customer is going to sign up. We need to quickly deploy some more virtual machines. So we didn't want that. How did we do that? Quick, who am I? David O'Brien, you've already heard my name. I'm a Microsoft Azure MVP for 8 years now, I think, 8 or 9 years. Been around the cloud ecosystem for quite a while. And 2 years ago, I founded Argus Cloud Security. I'm from Australia. I'm based in Geelong. The top right picture, it's a beautiful city of Geelong in Victoria, Australia. And if you've watched the Formula One just recently, it's close to Melbourne. You see the Formula One racetrack down here around Albert Park Lake in Melbourne. I also like to fly planes around Australia. So that's another hobby. If you really want to get in touch with me and talk about IT, startup, or aviation, here's my contact details. Always happy to get in touch with people in the community and help them get started in the cloud, be secure in the cloud. So quickly, why did we build yet another cloud security product? And here's a very, very strong statement, but it always gets people thinking and starts really good conversations. Because I believe that even though the cloud, the public cloud, could almost get a driver's license in most countries nowadays, as an industry, generally speaking, we're still getting cloud security basics wrong. And I don't believe, and I've never believed, that that's actually due to us not being able to detect issues, but mostly due to us not being able, from a time point of view, to actually approach or address any of these issues that were detected. Case in point, over and over and over again for over 13 years now, as a consultant, companies would ask me to come back into their environments and fix things, figure out which of the issues that a certain product found for them were actual security issues, and not just best practice violations in quotes. So that's when we started eventually thinking about how can we help organizations actually fix this issue, help them address their security concerns in the cloud. And we had a few golden rules, we called them, while building this product and starting the company. Number one, we went all in on Azure. I've never believed that lock-in is a bad thing. Especially when starting a startup, you need to be focused. So all in on Azure and PaaS, platform as a service, services, if possible. As a security product, it needed to have a strict focus on security, which really meant to us, again, PaaS, push most of these concerns over to Microsoft, our cloud provider, because arguably speaking, at an infrastructure point of view, at an infrastructure level, they're probably a lot better at securing certain things than we would be. Startup, we were bootstrapped, means we don't have any external investment. Really, that means money is tight, so free tier as much as possible, where PaaS also comes in again. Where we had to buy third-party solutions, or where we had to use third-party solutions, we decided that one criteria for a third-party solution would be they need to have a startup tier or need to have a free tier. Buy over build, strong fan, big fan of buy over build. Nobody wants to run their own Exchange server. That's why we're all buying Microsoft 365, Office 365. Yeah, so all of these things, if somebody's already built it, why would I try to build it again? If it's not part of my business, I'm just going to buy it. And automate everything. We had a very, very strong stance on whatever we did, we had to get it automated from day one. And this is our architecture diagram, really. There is no secret sauce necessarily, except for a bit in the code, obviously. But there's no secrets around how we built, how we architected Argos. Overall, what we're going to focus on today is in the middle, our function app. And in the lower left, of course, that's why we're here, our Cosmos DB account and our databases that we use for the backend of our application. So let's dive a bit deeper into that. Just generally, you don't see any virtual machines in here. Everything's PaaS. Our front end at 12 o'clock is a static website on storage accounts. We have not moved that to static web apps yet. I'm not necessarily sure if we will. If you've not looked at static web apps, have a look, different topic. We are using .NET Core for our application, but we run that on Linux because we don't care what operating system we're running on. So we just went with Linux, pretty much flipped the coin, and it landed on Linux because nobody should care what operating system you're running stuff on. Our database, as I mentioned, Cosmos DB, that's where we store our customer information, all the things we detected in customer environments. We encrypt all our sensitive information in these databases. And we use Key Vault to hold our encryption keys to really store sensitive information in the end, like certificates, other secrets. We use application insights, lower right, for logging, telemetry, observability, all of that, these entities. And then there's third-party stuff in the upper right that we don't have to go into today. But we use this application to now scan our customer environments on all three clouds, actually, on Azure, AWS, and GCP. So to do that, how did we do that? So let's dive a bit deeper into the application itself, the Azure functions, and specifically then after that, the backend, and why did we use Cosmos DB opposed to a SQL database, because that's easiest in quotes, because you probably find a bazillion blog articles on the internet dating back to the 1990s on how to do a SQL database. So why did we use Cosmos? Back to paths and functions and Cosmos. This is what we get, for example, looking at application insights. Without actually doing a lot and just a bit of configuration, using all these services that we are going to dive a bit deeper into, we get this amazing map, application map, a service map out of application insights that will show us where there's issues, what issues are there, how many calls, how many invocations, which one's a bottleneck, why is it a bottleneck. Really, really simple for us to dive into our application without deploying agents, deploying virtual machines, configuring IIS to forward telemetry to other endpoints. None of that required. All we had to do was put a key somewhere, and that was it, a bit of configuration. So the infrastructure itself, the application, as I mentioned, we use Azure Functions. We started with the consumption plan, the dynamic consumption plan for Linux. Why? Because it's free. Yeah. On day one, you don't know if you're going to have, and we didn't know as a startup if we were having commercial success, if we were going to have many customers. So we went with consumption plan. We're now on a premium plan for multiple reasons. But on a consumption plan, yeah, sure, you're going to have cold start issues, maybe that you can work around. But really, in the beginning, who cares? Your customers know you're an early startup, but who cares? Now we have over 120 functions across 2 app service plans, pretty much split into front and back end. We should probably split that even more, but if we wanted to, that's an easy code change. Again, because we are using this PaaS or FaaS, Functions as a Service platform, to do all of this. We don't have to deploy more virtual machines. All of this happens automatically. And as I mentioned, logging and telemetry all happens via application insights just through configuration. And speaking of the automation, we use Pulumi infrastructure as code to deploy all our infrastructure. And to deploy this function app, this is all we had to do. A couple of lines of code, and you can do the same in Bicep or ARM templates, obviously. But we use Pulumi here to configure what we want to see. We use system-assigned identities. Further to the middle, you can see system-assigned as a managed identity. So we don't have to configure any passwords. We don't have to hard-code any credentials anywhere. This is all taken care of by the platform, by Azure. So that if our function would have to go and get something out of a key vault or have to do something to our Cosmos DB backend, it would just know how to authenticate to that. So really simple for us to deploy this. And also, as a startup, sometimes back in the beginning, we also screwed things up or things fell over and we just redeployed from scratch. And that was easy enough because we started with our infrastructure as code approach, everything automated, and that made it really easy. So why functions? Just a couple of points on why functions. Well, they automatically scale in all dimensions, up, down, in, out, happened automatically. We didn't have to do anything for that, especially on the consumption plan. There were a few constraints, which is why we're now on the premium plan. Mostly that was due to memory before we refactored and split up into multiple app service plans. But really, now that we have quite a lot of customers on this, quite a lot of activity, we're now on the premium plan. But it also means we don't have to patch anything, no infrastructure. Yeah, you call it serverless. Yes, they are servers, but we don't have to worry about them. It's Microsoft's responsibility to patch them. I don't care if our function is running in a container or if it's actually a Linux VM. Don't care. It's probably a container. But that's Microsoft's responsibility to make sure they're patched. If one dies, they come back. Yeah, we don't have to do that. Which means that all that is something which means we can focus on our code. We can focus on the thing that is going to make us money. One of the most important things was the really easy integration with Cosmos DB, with our backend, and other third-party services via native bindings. You can really simply say anything this function does and spits out in the end, just chuck it into our Cosmos DB. There's a connection string configured somewhere, and it just knows whatever it returns gets put into Cosmos DB. So focus on our own business code. We didn't need to have OS experts on the team, which also applies to why Cosmos DB. We didn't need to have a DBA really that knew how to deploy a SQL cluster or a SQL always on across multiple availability zones or regions with quorum and all of that. No need for that. We just write our code, what really sets us apart from everybody else in the industry, and we make sure that that's good. We don't need to be good at deploying a virtual machine. Microsoft is good at that. Which also means that day 0 and day N questions were really already answered by the platform. On day 0, scaling was already answered by the platform. We didn't have to do that. Potentially, we just have to put some limits and constraints into the platform so it doesn't scale indefinitely or into infinity and costs us eventually quite a lot of money. But really, we didn't have to figure out how to do things. Functions also have an amazing local development experience, in my opinion. So onboarding of new team members now happens pretty much in under an hour. And the big one was also on the consumption plan, you get a monthly free grant of 1 million requests on your function and 400,000 gigabyte seconds of resource consumption per subscription. That's quite a lot, although we already blew past that by far. But initially, that's important. That's money you don't have to spend. So we had the Cosmos DB conference here. Let's talk about Cosmos DB, our backend. Similarly to the functions argument, why did we use Cosmos DB? Because it does come with a free tier, by the way. You can get one Cosmos DB account in your subscription with 1,000 request units per second and 25 gigabyte storage for free each month. That can already get you quite far, depending on how you build your application, how your queries run, how well you do your queries. That's going to get important in a second. You can already get quite far with 1,000 request units per second. Don't have to go too deep into request units per second, but it really depends on how you also build your queries. Microsoft charges you based on the compute, basically. They have to set aside for you to run a query and return the results. Well, very quickly, we got stung with $600 on that Cosmos DB backend, which ended up being the most expensive, but also the most valuable aspect of our application, really, before we started optimizing our spend here. We mentioned functions are really easy to use with Cosmos DB, and it's the same here. It was so easy. So much code we didn't have to write. So much time we didn't have to spend figuring things out. No patching required for Cosmos. Yeah, it's all taken care of by Microsoft. Database as a service, Microsoft patches the database, the underlying infrastructure. we don't have to do that. We don't have to figure out how to do the patching. There is no message to customers, excuse me, Argos is going to be down for the next hour because we're patching our database. None of that's required. Same with high availability, pretty much comes for free, depending on how you define high availability. Our data is replicated 4 times just in one region. And just a very quick news item, basically. A few days ago, Cosmos DB actually announced that auto-scaling can now happen from 100 to 1,000 request units instead of 400 to 4,000 request units. You can actually save quite a bit of money with that on database containers that aren't very active. To show you how we deploy it and how easy it is for us to really make changes also here. As an example, we only deploy into a single region our database for now, even though we have multiple databases, but for now, for compliance reasons, but for now we only deploy each database account into a single region. If we wanted to deploy it into multiple, because it's PaaS, we just tell the service here in the geolocations list down here towards the end, we add another location, another region, and that's it. We push the code and Microsoft figures out how to do it. We don't have to figure that out. The scaling was really important to us, similar to the aspect around the functions, that this is all taken care of by Microsoft. You probably see the pattern. We pushed to make sure that all of the issues that we might see as a startup, that we don't have to deal with them, we push that to Microsoft. Scaling, patching, all this ops stuff, we push it over to Microsoft because they're really good at it. So scaling on the database happens based on demand. And we can define certain limits on both sides where we want scaling to happen, and Microsoft just figures it out. If we know there's very static, very constant usage on certain containers or database containers, then we can also define that, and we can define that in code as well. Right now, we have roughly around 17 million requests every month. And because we use this PaaS service, Cosmos DB, it's actually, even without us doing anything, you go to Azure Monitor and you get this nice picture here where you can see all these metrics, the data usage, how many requests on each account and database and collection, how many documents you have, which is why I can tell you we have over 3.3 million documents in our databases, which roughly equates to probably 3.28 million cloud resources under management and 17 million requests. This is, we changed the filter to scale, to month. So roughly 17 million requests every month on this database. And we didn't have to change anything from when we had only 100 requests against this database to now 17 million requests. And we're not expecting to have to change really anything for when we have 10 times as much, because Microsoft takes care of that. We just sell the product, make sure customers are secure in their cloud, that they are taken care of. We build a really good product, but scaling is not a tech issue for us. So a couple of tips and tricks before we probably have to wrap up at some point. Free tier was really appealing to us, and it should be to you as well, especially if you're a startup, and startup in this case, by the way, lots of people glaze over when I say startup because they're working at this big bank or big enterprise or whatever. There startups inside of enterprises, inside of banks. If you're a team, you're building something new, you're a startup. Period. Convince me otherwise. We knew that our data will be very random. That's why we used Cosmos DB. We didn't want to spend so much time figuring out what our database schema was going to be to build a SQL database, really, knowing that the data schema is probably going to change in a month, in 2 months again. And we would have to do the whole exercise again and again and again. So having a non-relational database like Cosmos DB was actually really helpful. We could just chuck the data into our database and just query it back via code. And it didn't care about a schema. Super powerful for us because all the data we get from Microsoft, from Amazon, from Google, all these schema or these resource configurations basically are all very, very different. And we couldn't properly predict them. So having a pretty much chuck it in their database like Cosmos was really powerful. Speaking of querying it back, support for SQL API meant that all our .NET developers were super at home. They're just really easy adoption. Really fast read actions was important to us because we query our database a lot. All our scans that we do against our database, because we scan pretty much in real time. We scan continuously our customer environments. We needed to read so many times. And Cosmos is just great for that. However, on the flip side, our queries initially were really bad and expensive. Some of these queries consumed way over 5,000 request units. And initially, we didn't fully understand why. We were constantly seeing 429 throttling errors, where Cosmos DB said, well, you don't have enough request units available. So, and because we also went, oh, maybe we shouldn't scale beyond this number of request units because it would be too expensive, we were constantly hitting these HTTP 429 errors. As it turned out, the C# SDK that could help us build these Cosmos DB queries was really helpful, but it can also hide bad queries, hide in quotes, because without going into, because that could easily waste a week of workshop into query design, really how you query, how you filter can make a massive difference in Cosmos DB. So we luckily sent all our Cosmos DB metrics into application insights, log analytics actually, and we could just use this query here that you can see, and that's actually straight from the documentation. So don't worry about copying this, but feel free to take a screenshot. Take this query here and actually see which queries were consuming which or how many request charges. One gotcha though. On the right, the column, you can see request charge _s. It seems like request charge is actually a string, not an integer. So when in the documentation, and I do need to probably report that, in the documentation it says order by this string, it doesn't properly order by the number of the request charges. As you can see, 9 is not greater than 89.89. However, once you know that, once you've seen that, you can do your own sorting and filtering. You can export it to Excel and all of that and do your own thing. But it then tells you, well, this is the query. Maybe you shouldn't be doing it this way. Maybe you should be doing it that way. Or maybe we need to change our C# code to do it properly. Super helpful. saved us a ton of money to, in the end, use these diagnostic metrics to really give us more insights. It also turned out we over-indexed our documents. We really didn't have to index everything that we almost never or rarely queried on. Azure support was really helpful figuring out these things with us. They actually helped us reduce our costs so much. They saved us a lot of money. So they were worth their time and gold, pretty much, while improving our application's performance. We worked with them, had a few workshops with them via tickets and the startup team, and they made our application better and cheaper, which was just amazing. Highly recommend. And that's how we ended up building an application that can now help our customers find and really automatically investigate security issues on their behalf. No human needs to go and build a diagram like this. This is all done using Cosmos DB and Azure functions in front of that to really build this real-time diagram and paths. You can see the red graphs, and on the other side, on the right side, how somebody could potentially laterally move through your environment. And this is all powered by Cosmos DB and Azure functions. And with that, I want to say thank you very much for having me. I think I'm up to time. If you're interested in this, have a look on what it means. There's a free, absolutely free, we don't even ask for a credit card, free trial for you to take a look. But hit me up with any questions on Twitter, on email, whatever you want to use, if you have any. And thank you very much for spending the last, I think, 25 minutes with me. Thank you.
Yeah, that was an awesome session with lots of do's and don'ts, right, on architecture and also especially on the Cosmos DB side. We have few questions from the audience that we want to take them up. You mentioned about using Pulumi, right, for the infrastructure as code. Why didn't you choose some of the other tools such as Terraform or even Azure DevOps?
So we use GitHub Actions to deploy because it's free. We didn't have to pay anything for it. And we don't use Terraform, we use Pulumi because our application our front end is written in in Angular, TypeScript, and we can define our infrastructure also in TypeScript using Pulumi. So our developers, our engineers don't have to learn yet another language. Terraform is a completely different language that only applies to Terraform and nothing else. Pulumi's languages apply to everything else.
Thanks, David.
No worries. Makes sense. There's another question, David. One of the comments is that the person is heading a bootstrapped startup as well, and he has decided to make usage of Azure functions with Cosmos DB. But his question is mainly on the Azure function, using Azure function in real life scenarios, replacing a web API, especially the problem of cold starts. So did you face any such issue, and how did you get past that?
Yes, we absolutely did in the beginning, which was absolutely expected and accepted because we were on the consumption plan. It's a free plan. You get cold start issues if your application isn't running all the time. We absolutely accepted that. We communicated that to our customers that might happen, that they might have to click a button again for something to happen. They were fine with that because they knew we're a startup. Now we're on the premium plan where we don't have these issues anymore.
All right. I think we have a couple of more questions, so I will merge them together. So you spoke about being vendor locked, and personally, I have seen that startups they usually don't stick one vendor, and it was very good to hear that you have stick with Azure. What are the top 3 things that that made you to stick with Azure? And I'm sure security is one of them. And a couple of questions that to add on, right? And how security is handled in case of Cosmos DB, and how do you handle the sensitive information? And also, have you implemented caching strategy to lower the cost in terms of the queries that you're making?
Cool. So lock-in. If you're a startup and you're worried about lock-in, you're worried about the wrong thing. Yeah, you should be focused on building your product and building your application, not about how can I potentially move it over to a different cloud provider or whatever. You're worrying about the wrong thing. Two, we're not using any caching at this point. Our data also changes way too often for caching to make a lot of sense. Security, we use Defender for Cosmos DB. Woohoo! New service, new feature available in preview. Go enable it on your Cosmos DB accounts. That does protect our Cosmos DB account quite well. We haven't seen any alerts come out of it yet. Fingers crossed. Touch wood. All good. And I do have a blog article on that on my blog as well. That explains how to actually enable it, but it only takes 30 seconds. And at the moment, I think it's free.
All right. Thanks, David. I think those are the questions that we had from the audience. And thanks for the awesome presentation. I hear from customers on a daily basis, managing the infrastructure, especially at scale, can be hard. You must follow the best practices, use automation infrastructure as a code to do the things right. Especially when you do startup, and as a startup founder, you must always ready for that unpredictable surge in traffic that you mentioned in your session. I think you have covered most aspects of it. Sweta, what did you get out of this session?
No, what I really appreciate, Saji, is the clarity, David, that you had that, hey, I don't want to build what's already available. I just want to make the best use of all the past services and everything that's available on Azure to build my service quickly. So that clarity of thought is exactly what we build the platform for. So that's awesome, David. Thanks so much for your time again. And I'm sure all other startup founders, as well as anybody who is trying to build a new service or trying to scale it, will benefit from your insights today. So that's really great. Thanks
Awesome.
again.
Thank you.
Thank you, David. So, Saji, our next session is by Sindhu Chandran, and she's going to talk about migrating Apache Flink data pipelines to write to Azure Cosmos DB Cassandra API.
Okay, I think she's going to talk us through the changes needed and the best practices that she learned during the migration to Azure Cosmos DB Cassandra API. To introduce her, Sindhu is a data science and engineering manager at IBM. Her job involves helping other people realize the value from data, and I'm super excited to learn more about her migration story to Cosmos DB Cassandra API. Over to you, Sindhu.
Hi, everyone. Thank you for having me here today. So on myself, I'm Sindhu. I work with IBM Consulting. I work with customers mostly on data engineering, and I also dabble in data science for fun. And today I'm going to be talking about some experience that I recently had migrating Apache Flink pipelines, which were using Cassandra on-premise to Cosmos DB Cassandra API. So to give some context to what I'm going to talk about, this is a fictitious company called Kirana Cube. Kirana stands for your neighborhood store, community store, and this is also again a customer 360 kind of use case where they get data from multiple data sources, internal and external sources, batch and streaming data sources, and they have a need to make it available to their digital channels to provide an enhanced customer experience. And now Kirana Cube is on their journey to cloud, where they are invested in Azure cloud, and they would like to continue using their technology stack, which they have considerable investment on already, which is based on Apache Flink, Kafka, and Cassandra. So this they expect this to continue providing the same throughput and latency that they currently enjoy on their on-prem setup. So this is where the context is. And I will be talking mostly from a developer perspective as to what we need to be aware when we move from Apache Cassandra on-prem to Cosmos DB Cassandra API. So as you're probably aware, Cosmos DB is available in these different flavors. And one good thing for K2 or Kirana Cube is that they can continue using their Cassandra investment with hopefully minimal changes. The great thing is that it is via protocol compatible with Apache Cassandra. It is available as a fully managed platform as a service. So this means that there is no longer need to manage the nodes, clusters, what they were doing currently on-prem. So this saves considerable amount of time and money. And the third important advantage is that they can continue to use the client drivers and the familiar CQL that they were using on-prem. So this is the kind of setup that they are moving to, where they will continue to use their Flink and Kafka based data pipelines hosted on Azure Kubernetes service and writing to Apache Cassandra provided on Cosmos DB. From where the online application will read this data based on the requirements of the digital channels that this empowers. So this is my 10-point list of some of the things that I have learned during this journey. So, this is like mostly from a developer perspective, but covers some part of the architectural concepts that we need to be aware of when moving from Cassandra to Cosmos DB. So the first one is to know your DB, then you get going with tools. Then the next third step is about understanding the connector APIs and SSL setup needed. And very important, the dealing with request units for capacity. And then making use of insights to understand what is really happening there, optimization and error handling, and then making use of partitioning well, managing consistency, availability, and finally planning your data migration from on-prem to Azure Cosmos DB. So the first important item that you need to be aware of is the resource model. So this is the mapping to Cassandra for your Azure Cosmos DB. So you have this database account or the Azure Cosmos DB account created based on the flavor of Cosmos DB that you are using. So you create this for Cassandra, and the database here that you create maps to the Cassandra key space. And within the database, you can add multiple containers, and container is the term which maps to Cassandra table. And the items here map to Cassandra rows. So this is the first important part to understand. And the next thing to understand is about what is supported and what is different, because you might spend a lot of time otherwise, finding issues or trying to debug things which you think might work, but it is actually not supported. And there are also a lot of advantages which come with Cosmos DB in terms of the increased replication that it provides and things like that. So it is very important that we first review what is supported and different, so that we are not wasting time, later deciding that what is not supported will not work. We cannot live with what is not supported, or making sure that we know of the advantages that Cosmos DB provides. So these are the first two steps that I would start with to know your DB or know your Cassandra DB on Cosmos. And the next step would be to get going with the tooling. And here again, when you were on-prem, probably the CQL just came along and you might not have really bothered setting this up. And currently the Azure Portal does not really provide the complete SQL tooling on Portal. So it is very important that you have follow the instructions and the versions which is supported for SQL, and set this up on whichever OS where you want to work with, and make sure that you use the SSL settings as applicable, and make use the SSL parameter while connecting. So this would be the second step to start with to get your tooling set up for Cassandra. Okay, and this is where I think as a developer, you would probably spend some time on, because there are some differences here that might be needed, some changes which might be needed to your code to make sure things work seamlessly. And but very nicely, when we have a lot of examples available here already. So the first thing to start with that I would do is take one of the sample applications which are provided to validate your connectivity in the Azure environment. So you could use the Java, .NET, Python, or Golang packages. And in my story, K2 or Kirana Cube decides to go with Java v3. So this is the one that you download, and you can try to connect using this sample application to confirm everything is good on your Azure environment. So that is the first step. And as I said, there are these multiple options that DataStax Java drivers have in terms of v3 versus v4. And Apache Flink, again, supports multiple programming languages. So it supports Java, Scala, Python, and SQL. And in the case of Kirana Cube, they were primarily on a Java stack, and they already use this particular Cassandra sync or a connector that comes with Apache Flink called Flink Connector Cassandra. So it is very important to be aware that this internally uses the DataStax version 3 API. So when we use anything related to Cassandra, it is better to stick to the same. If you're going to use the Cassandra sync, that is one option. Then you would rather use the same compatible Java drivers, the version 3 of the Java drivers. And in case you want to go for Java version 4, you could implement a custom connector. So this is also a good option in case your code base is in Scala, or you want to use the version 4 for some advantages. Then you could create a custom Cassandra connector with the version 4 API. And Azure provides some additional extensions for Cosmos DB connection handling and retry logic, which is available in both the version 3 and version 4 APIs. The last thing to know in terms of code changes is related to the SSL connectivity. So you might not have been using this on-prem if you were in a internal environment, and so this is something that has to be done when we move to Azure. So you could use just the with SSL without a key store, and it would just pick up the default Java trust store, which would do for dev environments. But otherwise, you can use either the SSL options with Java v3 API or the SSL context with the version 4 API. So these are the options for SSL that has to be set up while connecting to Cassandra. So this sort of summarizes the key changes that are needed from a code point of view for your application to work. The next important lesson is about dealing with request units or RUs for capacity. So a request unit is defined similarly across all APIs supported by Cosmos. So it is the cost of the database operations expressed as a performance currency. So it abstracts the usage of these different CPU, IOPS, and memory. And you have to be aware that there are these different modes of setting up this which are available. So if you do not really want to be dealing with RUs, then you could use the serverless option, but you pay based on usage. You don't need to manage RUs here, but then there are some limitations in terms of the size of data and also the geo-redundancy options which are available. The next option is the provision throughput or manually managing your RUs. This can be done at the container or key space level or at the database the table level. So when you do it at the key space level, it works for smaller tables, and there is a limitation of 25 tables, and you might not have visibility into hot tables which are causing hot partitions when you do that. The database level, the table level gives more flexibility in managing your RUs. The provision throughput is a good option if your workloads are predictable with maybe some 20 to 25% variation. And the other option is the auto scale, which again you can set at a container or database level. So where you pay 1.5 times the cost of the provision throughput, but then there is the option to scale between a range that is set. So one option would be to start with auto scale to avoid any limitations of lesser RUs, and then based on your usage, you could provision throughput to better manage your cost. And this is one of my favorite parts of moving to Cosmos DB Cassandra API. So there is this beautiful drill down analysis of all the database operations. So you could go and check with time range at a table level. You could get throughput requests, partitioning details. So a lot of insights which are available, which you can further customize as well if you want specific metrics. So this is like a very useful feature that is a must to leverage when we move to Cosmos DB Cassandra. And this is again very important to know. So one of the first things that you face when you probably move is the rate limiting issues. So in the case of Kirana Cube, the jobs were failing because of lesser RUs, and you don't really want your jobs failing because of it. So you could just so there are two options. You could increase the RUs based on the latency expectations, and even if the RUs per second becomes a little less than what is provisioned, you really do not want your job to fail. So it is advised that you implement the Cosmos Retry policy, which is a custom version of the Cassandra retry policy. So this is available on as an open source GitHub project. So there is a Cosmos retry policy that is good to use to avoid these rate limiting errors. And this is again a must do to implement the reconnection policy. And Cassandra supports some 2 or 3 reconnection policies. The one that is recommended for Azure Cosmos DB is the constant reconnection policy with around 2000 milliseconds. So this is the option, and this is sort of a must have, because we found that without this, your jobs are likely to have connection issues. And so, as I said, there is this Azure Cosmos Cassandra extensions for Java, which has these additional settings and tuned settings which you can use, like the Cosmos retry policy. So this is also a good tool to use to better manage your connectivity settings. And finally, what we learned is that you get charged the same if your record is 0.1 KB or 1 KB. So it helps to sort of have a data model which is suitable to that, and important to analyze the read, write, and query volumes so that we can manage the throughput, provision RUs, elastically scale, do all of those. Coming to partitioning, if you have been on Cassandra, you must be already using the Cassandra partitioning for improved queries. So on Azure, there is a concept of a physical partition, which is the equivalent of your VM or compute unit, and it can have up to 10,000 RUs. There are 4 replicas of the partition created. So be aware that if you need more than one partition allocated, then you need to set your RUs to more than 10,000. So especially if you are having Flink-like parallel distributed programs where you want to be writing in parallel, or you want to be loading data maybe quickly or with a higher latency, and you might want to be aware that you need to provision more than 10,000 RUs if you need to have more than one partition. And the logical partition is the equivalent of the Cassandra partition, and the insights lets you monitor hot partitions. For example, if I had a table which is based on location, which had a partition based, a column based on location, and let us say 80% of the customers happen to be from Mumbai, then it would cause a hot partition, and that might not be the ideal partition key to use. But it lets you, the insights lets you catch these issues as well. So this is about partitioning. And again, you need to be aware of how the consistency maps to a Cassandra consistency and the cost implications of the same. So if you, based on, so there are these different options which are provided on Cosmos DB, and there is a mapping provided from how this kind of relates to the Cassandra level consistencies. So it is important to be aware of this in choosing your settings. And a plan, when it comes to availability, the node outages seem very well covered because there is a guaranteed 3 replicas which are kept in each Azure region. So the node outages are covered that way. And to cover zone outages, there is an option to deploy across availability zones when you create the Cosmos DB account. And when you deploy more than one region, you can have a highly available application, and you could be writing in one region. So this is the option that Kirana Q opts for, which is like single write region. So you write to one region, but the read is available from more than one region. So this is a good option to provide high availability and low latency. But in case you have a lot of write which is needed from multiple regions, this is supported as well, though with some possibility of conflicts which you have to manage. For each Azure region, there are 4 replicas of the data which are made available. So based on the number of regions, there are so many more copies of the data which is going to be kept for availability. Finally, on data migration, so you can continue to use the CQL-SH copy command for smaller data sets. And Azure, the documentation recommends Spark for larger data sets, but since K2 or Kirana Cube is a Flink shop, we used Flink instead, and this works well too. So this is on data migration. Some references. So the Azure documentation is extremely helpful, and the tech support were very helpful in helping us understand a lot of the changes and concepts, what is supported, and making sense of the RU concept, which was particularly new when moving from Cassandra to Cosmos DB. Thank you for having me here today.
Thanks so much, Sindhu. That was really great. Tell us about a couple of issues that you didn't have to bother about anymore after you migrated from Cosmos DB as compared to your earlier self-hosted setup.
Can you repeat that question? I think I missed a part of it.
My question, Sindhu, was can you tell us a few benefits that you saw after migrating to Cosmos DB? So that, hey, maybe this thing I didn't have to bother about anymore.
Okay. Yeah, all right. One thing is, of course, that I am not really aware of all the 25 nodes and the OS patching, that you get notified of every quarter. So we don't really need to be aware of that. That's number one. So all of that happens seamlessly behind the scenes. The second one is the insights. So I think that's like very, very useful to have that freely available for use to monitor what has happened and to monitor the throughput, the latency and partitions and all of that to optimize. So those are the two things I think which I particularly benefited from.
Okay,
Awesome.
adding to the question that Sweta asked, you spoke about 10 important things on the reasons on why you choose Cosmos DB Cassandra API. On the other side, we also have this Cassandra managed instance offering as well, right? Were you comparing those two before making this decision for this data pipeline use case?
In this case, not really. So this was not a decision which I made. So it was sort of, part of the strategy that the organization had. Yeah. So.
All right, got it. Okay.
So, thanks for hitting on some of the important points about migration planning there. One of the things you mentioned was, about the partition key selection and being wise with partitioning, right? So what were your learnings around data modeling? Since you were migrating, I'm assuming, there might have been fewer changes, but did you have to tweak anything with the partition key selection? How did you go about that?
Not yet, I would say, though we are kind of watching it. So we have a bit of a combination where we do have like some workload on-prem, but which isn't a whole lot. So we are also having a lot of new requirements where we are adding, to our data model and building for new requirements. So, and currently it's like mostly for new requirements that we are going to be building. So we are, I would say, watching it closely. So yeah, that's where it is.
Okay,
Sure.
I think you spoke about, I think you spoke about different scenarios where you have implemented the retry logic. You mentioned about a reconnection policy with, 2000 seconds or milliseconds, I would say. Is it particular to your scenario, or is there any recommended practice that you recommend others when they're doing this kind of migration?
In this case, this is something that I followed based on the documentation. Yeah, right. So because on-prem, we did not really use this particular parameter. So that was definitely a change. But this is the recommended setting. So there are some 2 or 3 reconnection policies that are provided by Cassandra, but this was particularly recommended in the documentation.
All right. I think you answered most of all the questions we had. Thank you, Sindhu, for sharing your insights, especially around one of the hottest topics these days for customers. We usually hear from customers that migrations can be sometimes tricky because you have to make sure that business continuity is always there and the whole solution works in the expected manner. Sweta, I think Sindhu mentioned about some of the things that beginners need to consider when they are starting with some of the PaaS services, especially on Cosmos DB. What's your thoughts?
Right, Saji. So like we hear often, right? When you're new to Cosmos DB, there are certain concepts that you might need to wrap your head around before your life becomes much easier, right? Because it's a scalable PaaS service, unlike your self-hosted instances. So things like partitioning, data modeling, the insights, all of that Sindhu has covered today. Thanks again, Sindhu, for sharing your experience and your pain points and insights on how you got past those challenges and leveraged Cosmos DB Cassandra API. So thanks so much again. It was great to have you here.
Thank you.
Thanks. Speaking of the concepts that new developers need to keep in mind, Saji, one of the areas that, as we know, developers who are new to Cosmos DB need to understand is how to model their data to make it scale, right? And many a times users will approach Cosmos DB and they apply relational concepts of data modeling that they are familiar with. And this nearly always results in a database that does not scale. As a horizontally partitioned NoSQL database, Cosmos DB requires unique knowledge and different techniques that allows for data to be managed efficiently and at scale. So let's take a look at this quick video that gives us a 2-minute view on some of these key concepts that you need to consider when modeling data for Cosmos DB.
Azure Cosmos DB enables incredible speeds, provided you choose the data model that best supports how you use your application. Data modeling is the process by which you establish patterns and rules for storing data across documents and containers, determining how data is accessed. Choosing the right data model for your workload results in better performance and faster speeds, especially as your database grows. While there are many nuances to data modeling, every project starts with the same question: whether to embed or reference. Embedding, also known as denormalizing, allows you to combine related entities into a single document. When used with read-heavy applications, results come in fast and ready to serve, no joins required. Embedding often leads to data duplication. With Azure Cosmos DB, duplications aren't a problem. The Azure Cosmos DB change feed helps maintain referential integrity across containers. Embedding falls short, however, when there's no practical limit to how much data will be stored and you reach the maximum size for a single document. It's also not ideal for write-heavy applications because it can lead to bottlenecked requests. In those cases, it's better to use referencing or normalizing like you would for a relational database. By creating unique entities that reference one another, you can break up write requests and break down large documents to speed up your application. Enable top speeds and seamless experiences at any scale with Azure Cosmos DB by implementing the right data model for your application from the start.
Welcome back, everyone. That's a must-watch video about one of the critical concepts on Cosmos DB, right? All right, Sweta, let's move on to our next session. It's on the topic real-time cosmic chat, presented by Divakar Kumar. Divakar is a senior software engineer at H&M, and he will show us a cool demo on how to build a cosmic chat application in real time using Azure Cosmos DB and Azure Functions, and also use the Azure Web Sub. That's one of my favorite topic as well. Let's hear from Divakar. Over to you.
Hello everyone, thank you for having me here. So welcome to my session. So today we are going to see how to build a real-time cosmic chat application using Azure Cosmos DB. So myself Divakar Kumar, I work as a senior software engineer at H&M. So our entire session is going to be based on an application that I have developed known as Cosmos Spark. So it is not only the chat application, there are other Azure components integrated within this, and how the Cosmos DBs are interlinked within these components that we are going to see in the next few minutes. So the main objective of this session is going to be like, I had a lot of learnings while building this Cosmos Spark application. So I'm going to share those learnings with you as well. And I just want to make sure like you understand the data flow between these different Azure components within this application, and some of the few examples when it comes to the design considerations. So when you want to choose the right partition key and how you can make use of the change field in order to do that. And the third part is like the most interesting part, because at the end of the day, like we need to show something in the front end, right? So we are going to see about the WebSockets and how it can be interlinked within the Azure Cosmos DB. And at the end, like we are going to see a real demo on this one. So to start with, so we are going to see the change feed. So this is going to be our real hero of this application. So if you are new to this Cosmos DB, change feed is nothing but a list of persistent records that keeps on listening to a particular Azure Cosmos container. So whenever there is an update happening in your documents, it keeps on listening to that, and it lists a sort of it sorts those documents in the order that they were modified. So by this, like, you will be guaranteed on the order that they are modified only within a particular partition key. So what I mean by that is, say suppose like you are querying on different partition keys, or if you are having a different partition key which is not suitable for the order delivery. Consider this example, like a retail industry, right? So you are adding an item A to a shopping cart, and adding an item B to a shopping cart, and then you are removing an item from the shopping cart A, and now you are checking out the items. So this should be in the order, because like at the checkout, you don't need to have the item A in your checkout, right? So in order to do that, you need to define your partition key in a well way. So what I mean by the partition key is, it is just a key for your document to uniquely represents your document, so that you will be logically differentiating a particular set of records within your container. And internally, what happens is, these list of records to a particular partition key will be stored in different physical servers. So that makes it easier for you to query a particular document when you are pointing to that partition key. So make sure that you are choosing this partition key wise when it comes to the ordered delivery as well, because the change feed works in a way with this partition key only, and you will be getting this in order only if you choose the right partition key. So as when I started working on this application, there were few questions that came up. So how to listen for a create or delete events, because the capability of this change feed is to listen for the any modifications with respect to the documentation, but it doesn't listen to any delete events that you are having within the documentation. So how to do this? So the one way of doing this is to soft update or soft delete. So by this way, like you can have a flag internally within your document, like say suppose like is update or is create or is delete. So you can point it to either true or false, so that you will be knowing, or you will be able to differentiate between a create and an update operation. And as well, you will be able to make sure that this is going to be a delete operation, and you can perform your business use case further on. And if you are worried about the documents being stored even after the delete operation, because now we are following a different approach, having the soft key to make sure that change feeds are listening to these events. So you can use the time to live property, which will make that particular document to be expired after that specific period of time. So this is one way of going about the differentiating your operations. Either it is going to be a create or update, because this would be the common scenario which everyone might be ending up with. Because if you are already using the change feed, you might be knowing this, like you won't be able to differentiate between the create or update operation and as well the delete operation. So this would be the right way to go about it. And there are different common scenarios where you can think change feed would be a better fit. So consider there are different data that is going to flow into this Cosmos DB, which you have as your persistence layer, and your change feed is going to listen on to these data or modifications of the document. So once you are listening to these events, so one way of thinking about this is like you can trigger an API at the downstream. So you can either have your APIs in your Azure functions or your app service, or you can even trigger a notification through the Azure notifications apps. You can think of a scenario in that way, or you can even think of a real-time processing scenario where you are using these real data for the stream analytics purpose. Or else you can even think of it way of like having this solution, this use case for the migration scenarios as well. Like if in case like you want to replicate your data to a different storage, or if you want to have a same copy of data into a different container, you can think of change feed as a use case for your business use case as well. And as when I started architecting this solution, so I end up in this question. So can we have multiple listeners on the same Azure Cosmos container? Because this would be the common scenario in the real world, because if you consider a single event, there might be multiple business use cases based on that. So in our application, consider there is going to be an user created event. So I can trigger a mail to that particular user, or else I can update the specific address or location of them in the Azure Maps that we are going to see in the demo. And also I'm going to push notifications into the WebSockets. So these are different events that you can consider for a single event, right? So in these many cases, like you might end up in having multiple listeners on the same Cosmos container. So is this possible? Yes, this is possible. The way to do that is using the leases. So the leases is nothing but the concept of the documents which has the checkpoints for your Azure functions to work. So consider this is going to be your Cosmos DB change feeds, and there are going to be different Azure functions that are going to listen on to these change feeds triggers. Okay, so whenever a particular Azure functions is failing or shutdowning for some reasons, so the leases is going to contain a checkpoint which allows you to go back at the exact same place, like once it restarted the Azure container. So you can either create, you have two options to go about this. So you can either create one lease per container per functions, or you can have a shared leases container. So in the first case, there is a trade-off, like because now you need to incur additional costs, because the leases is also going to be a new container, and you need to provision throughput or for those containers as well. Or else you can have a single lease container that can be shared across multiple Azure functions, which can be handled for different use cases. So this is one way of going about this, and this is the best practice. But there is a trade-off that you can think of in future in this shared leases container as well, because consider a scenario where you end up adding more and more subscribers to this particular change event. So you might reach this situation where you need to increase the throughput average consumption. That again also gonna consume you some amount, like where you need to reconsider on increasing the throughput for the particular container. So the other alternative for going about this is using the event grid solution. So the event grid solution is the publisher subscriber model. So there can be many event sources. It just publishes this event to this event grid, and there can be many subscribers that you can have as an event handlers. So the publisher doesn't know, it doesn't want to know like what the subscriber is going to handle in the later stage of the time. So in our case, you can have one Azure functions that is going to be a Cosmos DB trigger for listening those change feeds, and you can publish these events to the event grid. So now what happens is you can add as many subscribers as you want in the future as well, and you are not going to incur any additional cost with respect to the container. So this is one way of going about this, and that is how I have modeled my application as well. And the next part is like the next question that I had is how to publish the real-time events to the front end. So whatever we have seen till now is good. Like whenever there is a change in the database, we are able to capture it in our backend system. But how to get it all the way out to the front end? So in our application, so our front end is based out of the plain JavaScript and HTML page. So how to go about this one? So the one way of going about this is using the WebSockets protocol. So now we need to think of a different protocol other than the HTTP, because if you are using HTTP protocol, you need to use a long polling mechanism where you will be pinging for an quite period of time to the server, like whether the data has been reached or whether the data has been changed. So only then like you will be receiving those real-time events in your application. But WebSocket is a different concept or different protocol on its own, where you will be opening two-way communication between your server and the client, which makes it easier for you to publish the real-time events, which gets delivered in a real time, near real time. to the front end. So one way of using this, using the Azure services is I have used the Azure Web Pub-Sub service. So this allows you to handle this WebSocket connection between your client and the servers. So as it is shown in the diagram, so there can be a number of clients to whom you can broadcast the message to, and from the clients also you can directly communicate with the Azure Web Pub-Sub service without going through a round trip to a server, different servers. That is also possible. So we considered both of these scenarios in our application, which we will see in a bit. So the way to do that is using the sub protocol that you could see here. It is json.webpubsub.azure.v1. This is a sub protocol that you need to mention whenever you are initializing this WebSocket within your JavaScript. So if you have done this step, so now you will be able to interact with this Web Pub-Sub service directly from the client without having an intermediate server in the middle. So now comes to the architecture of our Cosmos Spark application. So this is going to be our device skyline. So consider this is going to be any browser or any user. So they are going to be reaching to our plain JavaScript HTML application that is hosted in the Azure Static Web App. So it is on a hosting platform where you can post the front end and as well the back end as well. And you will get a lot of other features which I'm not going to cover in the session because it is a different session on its own. So from this front-end application, we are going to call REST APIs. So we have defined REST APIs in the Azure functions as an HTTP trigger. So because our entire application is built out of a serverless mode, event-driven architecture. So that is where all of these HTTP calls goes into the Azure functions. And from the Azure functions, we are persisting the data into the Azure Cosmos DB. So this is where the vital role takes place or kicks in. So now the different events will be fanned out to different subscribers. So from the Cosmos DB, the one way of listening to these events is using the Cosmos DB trigger, or the other way is using the change feed processing library. But the efficient or an easier way to use it is using the Azure function. Internally, this is also using the change feed processing library, which allows you to listen to those change feeds and publish those events to the downstream. So after it has reached to this Cosmos DB trigger, what I am doing is I am publishing this event to an event grid topic, as we have seen earlier. The reason for doing this is so that like whenever in future, like if you want to add more subscribers to a particular event, you will be able to do that without incurring additional costs. And you can add multiple subscribers to a particular topic. So that is what it is depicted over here. And at the end, from the subscribers, you can either directly reach out to Web Pub-Sub service, which will publish or broadcast the message back to the front end. So that is how the real-time events are published to the front-end application, where they can see the chats are getting updated or the notifications are getting in the front end. Or there is a way for the front-end applications to directly communicate with the Pub-Sub service as well with our sub protocol that we have seen earlier. So there might be a case where you don't need to persist the data, or you don't need to go through a set of intermediate servers, and you need to directly communicate with the Pub-Sub service so that it directly reaches the other clients who are listening to these events. One thing to consider here is like whenever you type a message, like in your WhatsApp or in your Facebook, like you would have seen, there is a little pop-up showing someone is typing a message, right? So in this, like you don't need to really store these messages in your Cosmos DB. You just need to publish these events directly to the Pub-Sub service, so that the other clients or the one who you are interacting with should know like you are typing. So for that scenario, you can directly communicate with the Azure Web Pub-Sub service. So now let's consider some of the design consideration that I have taken, like when I was building this the Cosmic Chat application. So one of the main thing I considered is replicating for the multiple partition keys. What I mean by that is, Consider this is going to be one portion of our application, that is going to be the chat application. Here you could see in the leftmost side, you can see list of chats that you have already communicated with. So these are list of people that you are already communicated with. So the one way of querying these or getting these list of documents would be going by the user ID, the current login user ID. So that would be the better partition key for this set of operation. And for the rightmost corner that you could see here is the list of messages for a particular chat item. So the one way of going about this is like you can consider having chat ID as your partition key. So there are different partition keys for different purposes here, but you are having only one business use case. Like you just need to type your message and you need to consider both these scenarios in your real world. So one way of doing this is with the help of change field, because consider like there might be other scenarios as well, like an application can be a read heavy or write heavy application as well, or there might be a similar case where you might also end up like where you want to query on different parameters and you want that to be in an efficient way. So you can make use of change feed in order to replicate these partition keys or replicate these documents into two different containers. So we can see that how it is done in this Cosmic Chat application. So Cosmic Chat is the container where all the messages are stored. So you can see I have chosen chat ID as a partition key for this container. So whenever they click on a particular chat item, so I'm going to use this chat ID as my querying filtering option, so that all the messages for that particular chat will be retrieved in a faster pace. And once I done this, like there is a change field listening to this container, which will duplicate this data to a different container with a minimal set of data. So I will be normalizing these data as well, which is required for me to show that left portion of the chat application, where I need to show to whom I sent message and what is the last message that I have sent, and also the icon of it. So those things I need to store it in a different container with a different partition key. So now the partition key that you could see here is the user ID. So whenever I retrieve the left portion of the screen, I use this user ID as the partition key, and whenever I retrieve the list of messages, it is going to be the chat ID. So this is one way of going about like how to replicate your multiple partition keys. So let's see a quickly demo on this one. So let me refresh it because I have opened this for a long time. So the PubSub service, I have made it available for 1 hour. So let me refresh this. So in the topmost portion, you could see this is going to be the Azure Maps that I have integrated with this application. So as when I log in, you could see there are a list of markers getting updated. So this is based out of an Cosmos DB container, which is having a change feed, which is going to publish an event to the web subservice so that like it updates each of these markers. So as when a new user is going to join in, so that marker is going to instantly get updated in this particular page. So let's see, like this is going to be the chat application. And the one that you could see here is the list of tasks that are assigned to a particular user. So these are list of tasks, like once you complete a particular task, like sending hi Cosmos Park to a particular user, you will be awarded with 2 points, and you will be able to see that the list of scores is getting updated in a real time. So these are different scenarios that I made use of the Cosmos DB in order to work with these different things. So if I chat someone, like if I chat with someone from the New Delhi, so I will be rewarded with a point, 2 points, and I will be a top scorer now. So that will be a different use case. So let me also log into a different account so to show you how the chat application works. Let me have it side by side. Okay. So now I'm going to interact with a different user. So when I start typing, you could see there is a little pop-up showing here, Divaka Kumar has started typing. So this is something I have published directly from the client to a web app subservice. And whenever I post a message here, so that will go about like it will first reach us to the web app subservice, so that like it shows you like Divaka Kumar is typing, and then like it will reach us the so there is a cold start because I am running in the Cosmos DB serverless mode. So you might expect a cold start for this one. And you will be able to see like the messages has been retrieving, and it will be shown in the in the other users type. So this is how the change bit works. So and the entire flow works. So I will get back to the slide. Maybe I will show you a slide on how this thing works. So this is the entire data flow that you can see in the entire application. I'm not going to confuse you with this entire flow. So consider, I'm just going to consider one of the scenarios that is going to be the leaderboard update. So there are different containers I have taken into consideration for this one. So one of the main thing is the Cosmic Chats, where the list of messages gets added. So I'm the one of the events that I'm listening is the Cosmic Chats.updated event. So I'm going to publish this event to the event grid subscriber. So it is going to update a new container where I'm going to store a normalized data of it, and I'm going to use that for a different logic. So there is a different container known as Cosmic User Task, which lists all the tasks for me for allocated timestamp. So this will subscribe to a different container, which will update the leaderboard score, and it will trigger a different change feed event, which will again call a different subscriber, which is going to be a leaderboard score update. So that is how the entire flow works. Like now from this subscriber, it directly publishes the message to the web app service, and then it publishes the events to the front-end application. So this is how the entire flow works within this application. And I think that's all I had for sharing with us. Yeah.
Thanks, Divakar. I think that's an awesome scenario and the demo you covered. Even at Microsoft, we know that one of our favorite collaboration tools team is using Cosmos DB to enable so many features using change feed. I think it's one of the favorite topic among developers as well. Can you talk more about what are the deployment configurations of each resources that you spoke about, like Azure Static Web Apps, Azure Functions, Event Grid, and then PubSub? And have you estimated the total cost for this application? Because this looks like an interesting app. Probably other developers would be interested to build something like this. Yeah.
Exactly. So since this is going to be a demo application, so whatever I have considered is in the serverless mode. So right from the Azure function, it runs in the serverless mode, and as well the Cosmos DB that is going to run in the serverless mode. So there are different scenarios where you need to consider different modes as well with respect to the Cosmos DB. So in Cosmos DB, there are other modes like manual throughput and auto provisioning. So if you are gonna go ahead with the Cosmos DB as a serverless mode, there is a trade-off, like you need to note down. So because now you will be having only single region capability, so you won't be having this global distribution or the feature that you have with other modes. Like you don't have that in the Cosmos DB serverless, but it just works fine for me since this is going to be a demo application, and the cost is much cheaper, but haven't gone through or looked at it because I just completed this entire application just a few days back. So it might take for me time for me to consider those things as well. But I would say like since I have considered Event Grid as my intermediate PubSub pattern, so there is a cost reduction in that as well. So now I don't need to pay an extra cost for having different leases per function or having a shared leases. So there is an per million free connections that you will be getting for the Event Grid as well. So that is more than sufficient for this demo application. But in the real world, you need to consider other things as well when you are considering designing the application.
All right. I think you answered most of my questions. Sweta, do you have a question?
Yeah, so Dibakar, you've used functions at two places in the architecture, to write to Cosmos DB and also read. So just was curious to know what was your experience of that integration? What were some best practices that you learned?
Yeah. So one of the easiest way to listen to these change feed is using the Cosmos DB trigger, which uses this push model. So you don't need to pull the model, you don't need to have your own page. Like there might be a scenario where you need to have your own page of pulling these messages from the change feed. But this acts in a way like whenever there is an message or modification to a particular document, it acts as in a push model. So the Cosmos DB trigger kicks in, or else you can design your own library out of this change feed processing library, which would incur you an additional time. So if
Right.
you want to make already an existing usage of the Azure functions, you can go about with this Cosmos DB trigger, or else you can rely on the change feed processing library, because internally Azure function is also gonna use the CFP for the processing.
Makes sense. Thanks again, Divakar. This was a wonderful session, and every business does have its own website, so many of them may need to offer differentiated experience to their customer. And looks like a chat feature like this will be super helpful for other developers and app providers as well. Right, Saji?
I think you are spot on, Sweta. It's a real challenge to create something like this, like global scale real-time application, where you can collaborate with among others, right? So thank you, Divagar, for this amazing session with the cool demo that you
Thank you for
showed.
having me.
You have shown us how easily it is to solve this type of challenges using Cosmos DB and various components on Azure. Thanks again. All right,
Thank you. Thank you so
let's
much.
move to our next session. We have one more interesting speaker today. Our next presenter today is Rajdeep Sengupta. He's just 19 years old, who is just completing year one of Bachelor in Computer Science. He's going to talk about how he went from not knowing what Cosmos DB was to build a full-fledged full-stack web application in 1 month. He has built a versatile app called Bookly that uses the Cosmos DB with cognitive search. We are excited to have you here and to hear more about your learning and also the journey with Cosmos DB. Over to you, Rajdeep.
Thank you. Hey everyone, myself Rajdeep Sengupta. I'm a first year BTech computer science student from Hate Institute of Technology. So let's get started with the session. As the session name suggests, hearing about Cosmos DB to building a full stack web app within a month with Cosmos DB. So there will be a mixture of tech and story on how we built a web app within a month that reached Microsoft Imagine Cup finals and top 8 in India in education category. And all of this using Cosmos DB as our main database. And this is going to be a basic session on why we choose Cosmos DB over any other databases, and how to create a Cosmos DB database, how to integrate with it with cognitive search, and also how to connect it with Next.js web app and with the Mongodb API. So first things first, how it all started. It was around end of November when I received a mail from Microsoft saying that register for the 2022 Imagine Cup, and the email is so good. We thought like, why not? We should give it a try, and we registered for Microsoft Imagine Cup. So when we were just reading through the rules and regulations, we noticed a point saying that we must use the Azure tool or Azure service in the project. Back then, we have completely zero knowledge about what is Azure. We researched about Azure a lot, and after a lot of searching, reading the blogs, official documentation, and videos, we decided we'll use Azure Cosmos DB as our main database, Azure Cognitive Search for advanced search feature in our web app, Azure geocoding and geolocation APIs to enable location functionalities, and Azure Maps for the map functionalities. And from then, within the first week of January, we were able to build a full stack web app with Azure Cosmos DB as our main database. Now, there are lots of reasons why we choose Cosmos DB as our main database over MongoDB or any other database. So move on to that part. So why we choose Cosmos DB as our main database, and why you should also choose Cosmos DB as your main database. So the first point is ease of use. It is really easy to build apps on using language of your choice with SDKs for .NET, Java, Node.js, and Python, or your choice of drivers for any other database APIs, like we used MongoDB in the case. Azure Cosmos DB schemaless service automatically indexes all your data regardless of data model to deliver blazing fast queries. And the whole database is fully managed, so there is no maintenance. The next part is, as we are students, this point is really important for us. It's really cost effective. As it is a fully managed database service, automatically there is no touch, no maintenance, no patching and update. So it saves developer time and also the money. It has cost-effective options for unpredictable workloads for any size or scale, enabling us to get started easily without having to plan or manage our capacity. Its serverless model offers spiky workloads, automatic and responsive service to manage traffic burst on demand. And as we are using Next.js, and building a serverless app is the best suit for us. It has auto-scale provision, throughput automatically, and it instantly scales capacity for unpredictable workloads. Now, the next point is speed and scalability. As our app is kind of a marketplace, we had a lot of data and we need it super fast. Cosmos DB offers real-time access with fast read and write latencies globally, and throughput and consistency, all backed by SLAs. It also has multi-region rights and data distribution to any Azure region with a simple click of a button. While starting, we don't know the amount of data we will have, and here comes Cosmos DB's independently and elastically scale storage and throughput across any Azure region, even during unpredictable traffic bursts for unlimited scales worldwide. Now, the next point is MongoDB API. The Azure Cosmos DB API for MongoDB makes it really easy to use Cosmos DB as if we are using a MongoDB database. You can leverage your MongoDB experience and continue to use MongoDB drivers, SDKs, and tools by pointing your application to the API for MongoDB accounts connecting to screen. And it's really helped us as we have previous experience with MongoDB, so the learning curve is almost zero for us. And one who had already experienced with MongoDB, for them it's also going to be a zero learning path for using Cosmos DB. And with Mongoose on top of MongoDB, we can easily use .save, .find, and more easy to use fast new functions for fast development. Now the point is integration with Azure Cognitive Search. As we choose Azure Cognitive Search for advanced search functionalities in our web app, it was really easy to integrate Azure Cosmos DB database with it. Within a few clicks, we are all set to search data in our Cosmos DB database. Now let's move on to creating a database in Cosmos DB, how you can create a database in Cosmos DB. So let's get started to Azure Portal first. After signing in, you will be redirected to a dashboard like this. You may not have any recent resources like me if you're trying out Azure for the first time. You can find a lot of options, but for now, we can start creating a resource. So you can just click on the Create Resource button on the top left corner, and you can just search for Azure Cosmos DB. You will find a page like this. Just simply click on the Create button to proceed. After that, you will have a bunch of options. Let's understand them. So the first one is Core SQL. This is the Azure Cosmos DB's native API. This uses a SQL query language, which is super popular. The second option is Azure Cosmos DB API for MongoDB. You can write simple MongoDB code and use Mongoose on top of that for your application. And with that, you use Cosmos DB as if it is MongoDB. The third one is Cassandra. This is also same as MongoDB, and you can use Cassandra database instead of MongoDB with the Cassandra API. Next one is Azure Table. It is suitable if you have existing code for Azure Table. Azure Table is yet another service offered by Azure. The last one is Gremlin. It's a graph database. If you have a graph database workload and that uses Gremlin, then it's the best option for you. Now I'm going to use Azure Cosmos DB API for MongoDB, and I'm going to choose MongoDB from those 5 options. The next part, we have to fill up all the details. I will use Azure Student Subscription as I have it. You can choose whatever you have. Then choose the resource group. For now, I'm not going to explain what is a resource group, but if you are trying Azure for the first time, most probably you will not have a previous resource group. So you can create a new resource group. Now for the account name, you can choose any. There are some limitations. You cannot use capital letters, or there are some basic limitations. You can just take care in that mind, and you can choose anything for the account name. Now for the location, you can choose any Azure location, but try to have a database near to your users. Let's talk about capacity mode. For choosing a capacity mode, you can just refer to this table and you can just choose what you want. But in a simple words, if you have a predictable recurring traffic and you want low latency, then go for a provision throughput. And on the other hand, if you don't have a predictable workload, then go for a serverless one. This will be going to be a benefit for you. I will choose provision throughput for now and have a rest as it is. Now see the global distribution section. I will disable both options because for now I don't want to distribute my database in multi-region. You can enable them to have more latency and better performance of your database all over the globe or the regions you choose. But remember, that will come up with some additional charges. So in the next section is networking. The first one is all network, means you are allowing all networks, or you can say everyone who has their credentials, database credentials, they can connect to you. The next one is public front end. This is when you want your web application or your mobile application only to connect to your database. Now the last option is private endpoint. If you have a private server and only want that private server or only then want that private server's IP to connect to a database, then you can choose this option. For the sake of the simplicity, I'm just going to use all network in this demo. Now the next one is pretty simple, is the backup policy. You can have a periodic backup and continuous backup, which is always on and which will always replicating your database to somewhere else. For this, I will be choosing periodic backup for 240 minutes in each hour. It will back up my data, and choose the backup retention to be 8 hours. That means a backup will be there for only 8 hours. After that, new backup will replace it. For the rest, it's pretty explanatory. Now the next point is encryption. I'm going to choose service managed key because here you don't need to manage any key. Azure will take care all of this. They will encrypt your database and you don't need to worry anything about the keys or anything. The second option is customer managed key. Here you need to manage your keys. The customer has the keys, so you need to manage them. So for again the sake of simplicity, I'm just going to use the service managed key. So the next one is tag. If you want tags, you can add them, but it's an optional one. So I'm not going to add tags for this demo, but you can definitely add tags for better understanding. Now you can just review all the option until it validates. So you can say the estimated account creation time is 2 minutes. The subscription I'm going to use is Azure Students. The resource group is Clueless. Location is West US. The account name, I have chosen Rajdeep account. The API, I'm going to use the Azure Cosmos DB for Mongodb API. The capacity mode is provision throughput. You can also choose serverless. The geo redundancy is disabled, and the multi-region rights is also disabled. For the backup policy, I choose periodic, and the backup storage redundancy, geo redundant backup storage, I have chosen. For the connectivity method, I chose all network because for this demo, I want all the networks who have the credentials to connect, to be able to connect to my database. Now you can simply click on the create button. After that, you will see a page like this where your database will be created and the deployment will be in progress. You have to wait for 2 to 5 minutes to finish this process. If the process is successful, then you will see a page like this. After, you can just click on the go to resource button and go to the database dashboard. Now you will find a dashboard like this, and you can get pretty overwhelmed seeing this much option. Just simply click on the data explorer and you will be redirected to a page like this. All the data will store, can be browsed here. Here you can also create data manually. Now came back to a dashboard again. You will see there is an option saying connection string. So now here we are entering the part how you can connect a Cosmos DB database with a Next.js app. So now in the left navbar menu, you can see the settings connection string. And if you click on this, you can see all the credentials you have. You have the host, port, primary password, secondary password, primary connection string, secondary connection string, and the SSL. For this, you don't want this space to be shown to anyone. So I'm hiding all the data I have here. So you can just come here and copy the primary connection string from here. Now I'm just going to show you some code snippets that will exact the code snippets that we wrote in our application and explain them to you. First, you can just create an XJS app using npx create next app and your application name in your terminal. After that, you can simply add a new folder named database and create a connect db.js in it. You can name them anything you want. So first, let me tell that I have also installed MongoDB and Mongoose as a dependency in my app. So in the first line, I'm simply importing Mongoose, then building a function named connection DB. First, I'm checking if the client is already connected to the database or not, because in Next.js, each time we run the connection DB function from the client side, this will connect to the database, but we don't want a single user to connect to the database for the multiple time. If a user is already connected to the database, we just return from the function. Then if that user is not connected, I'm just simply using the mongoose.connect function and using the Mongo URL. And I'm just put the Mongo URL in the env folder, because this is what you don't want to expose publicly. Now from then it's going to connect to the database. Now after that, we are just simply saying that if the Mongoose connection is connected, then we will be just console logging that it will connected to the database. And if there is any occur that will happen, we'll just simply log that error while connecting and the error itself. Now in the next part, we'll be adding some data to the database. Now let's see how we can add some data in the database. So first of all, we need to build a schema. And again, I'm just importing the Mongoose in the first line. Then we are just building a schema named cell book schema. And this is the exact schema we used in our project named Bookly. So here we're just simply using the Mongoose function, so new.mongoose schema, and specifying all the things we want. So here you can see the name, author, photo, condition, category, and all other stuff. So I'm just marking something that required, or if the data is required or not. Now in the next part, I am just simply exporting it as a model. Now in the next part, let's just add some data to the database with this function. So first of all, I'm just simply importing the connection DB function from the connection DB from the database / connection DB. I'm importing also the cell book from the database / model / cell book. This is where we placed. This is the path of the function, or you can say the files. Now I'm just validating the data second time in the backend. So after we get all the data from the request.body, we are just destructuring all the data. And then which are the required fields, I'm just giving a if-else statement for that. So if there is no name, no author, no condition, and all other stuff, if these are the required things, if they are not in the, then they don't come from the front end, this is just going to return a error saying that please fill all the fields. Now in the next function, we are saving all the data in the database. Now you have we have all the data, and we are just saving all the data using the new cellbook function, and using the .save function, we are saving it all in the database. Now at the end, I'm just giving a status code of 201. That means something new is created, and just returning the data that is actually created in the database back to the front end. Now if you store a data from here, just simply the data will be look like this. There will be already a database data created. There's a new, it will be created as _id, and as we are using the MongoDB API, this will be called object id, and you can find the object id there. Now you can see the name, author, photo, and all the things we have in schema. that is here. As you can see, the school is not a required field, so you can just simply skip that. That will come with a empty string or can become with a null in your database. Now this is all from my side, so thank you for having me, and I will want to thank Azure Cosmos DB to give me a chance to talk in this conference.
Thanks, Rajit. I think it was great to hear from one of the Imagine Cup finalists here. You covered about how you started with this application in QuickTime, and you also demonstrated step-by-step instructions from creating the account to coding to deployment. I have a question on behalf of beginners on Cosmos DB. What are the 3 most useful Cosmos DB resources that you would recommend for any of your friends, or even for the beginners on Cosmos DB who want to actually get started with Cosmos DB?
So the most important thing is like the official documentation. The official documentation is super good. You can just browse through it and you can find everything in it. But if you prefer videos, you can just see the Azure Cosmos DB channel itself. You have the Microsoft India channel where we just find something. So we have used this too only, and we just covered all the things in that we required.
Thanks. Okay. Yeah.
Great. Thanks, Rajdeep. Can you also talk a bit about your application stack and architecture and what other Azure services you've used?
Yeah, so you can find our application in bookly.versal.app. So this is a simple application where you can simply donate your book to its nearby NGOs. There's also, you can sell your books, sell your secondhand books. You can just buy from there. You can also search through your college, because in the most of the cases, if you are in college, you are in school, most of the time you are searching the books for your to the seniors, not going outside of the college. So you can just search the book in your college if any one of your seniors have the book there. So in that case, we just use Next.js, and this is a totally serverless app. We use the Next.js API routes for this one. And also here we use Azure cognitive search, because we don't want to implement the search filter, because we don't have much time to build all the search functionalities, like everything. So use Azure cognitive search for that, and with a simple few clicks you can just import the database, and Azure cognitive search will do a magic, and you have all the indexes, everything just lined up for you. You can just click on the next, and you don't need to configure anything to just filter to get the URL to filter all the data. And also, if I say in the Azure we use the Azure geolocation and geocoding APIs, because we are just showing the area where the book is from. Because if you are buying a book and you need to know from where the seller is, you can go for online payment, or you can just go to him and take the book. So you are just allowing the users to see the area from where the book is. Also, we are using the geocoding and geolocation API for the search functionalities in the where we use the actually you can search the nearby NGOs with a simple 2 to 3 clicks after filling out a form. That with Microsoft search APIs, we are just creating all the data or all the nearby registered NGOs within a 5 kilometer, and we are all showing all the perfect latitude with the perfect latitude and longitude on the map with the Azure Maps and geocoding, and with the help of geocoding and geolocation API.
That's awesome. So this will be super useful for all the students, and like you said, if anybody has old books to give away and stuff like that. So that's great. And Rajdeep, you are still studying, and I'm confident that you'll be creating more apps down the line. So what's your next project using Cosmos DB?
So we are using a mobile application this time. So this is going to be a mobile application that you can just scan any medicine. You can just scan any medicine. You can just fill out your data and everything. Just you can scan any medicine, and it will tell you if the medicine is counterfeit for you or not. Just if you are just going to a store, just scan any medicine, and it will be saying you if the medicine is counterfeit or not. You can also see if there is in the online market, where you can buy, what the price is, what you need to look up for that, like what are the things, like what is the name, what are the compositions. Composition is not the most required part. In the most important thing is, can you consume the medicine? If you have like diabetes, if you have sugar, there are some medicines you cannot consume. So if it will give you a red alert. There are some in the medicine section, like medicines and all other stuff, there are also some like expiry options. So the AI will detect all of this and give you all the expiry dates of that medicine. So you're not going to consume any medicine that is already expired and all.
That's awesome, Rajdeep. Thank you for your time. This was a great session. Firstly, you showed us how to use Cosmos DB as a virtually limitless database and how other full stack developers can use it to build applications quickly and deploy the app to cloud with static web app generators like Vercel and static web apps. And I'm also super excited to see your enthusiasm about solving more of these real life problems. Isn't it, Saji?
Yeah, I think I'm inspired by this session. He spoke about the applications that he's planning to build. It's great to see that,
Yeah.
how he has used the full stack web app using Cosmos DB in QuickTime by leveraging all the capabilities. He talked about the SDK capabilities that we have and the learning curve, which he mentioned as very simple. And hope to see many more applications from you, Rajdeep. Thanks again for joining us today. Sweta, I think it's time to move to our last segment.
Yep, Saji. So our last session for APAC segment today is by Subhashish Ghosh. He is a cloud solution architect at Microsoft, and he enables the customers to build great solutions using the Azure platform. Hey, Subhashish. Subhashish is here to talk about how he enabled one of our Microsoft customers to migrate a graph solution from MariaDB and MongoDB for fraud analytics using the Azure Cosmos DB Gremlin API for faster performance, higher resilience, and better TCO. That sounds like a very interesting story of choosing the right database for the right use case to me, Subhashish. So over to you.
Yeah, hi Shweta, hi Saji. I hope I'm audible.
Yes.
Yeah, we can hear you.
Yeah, thank you for having me. Really appreciate. So I'll quickly jump into the use case. As you've already articulated, right? It so happens that I kind of worked with a lot of customers, and this specific use case. Again, though we are deep diving into this specific use case, where let's say the customer is kind of created, let's call it real-time analytics on specific type of transactions which are coming through credit cards. But the learnings and the key design decisions that we will cover, I'll try to cover given our time's scope, definitely applies if you're also building real-time, let's say, recommendation engines, or for your e-commerce portal, or you're building social media analytics platform for let's say building a personalized marketing campaign and so on. So for this particular use case, right, initially the customer had built, let's call it a solution involving what we call traditional RDBMS, databases. So when you build a graph solution on top of that, we basically call it a RDBMS vertical graph solution. And they use a schema, basically, I've taken a kind of a representational image, is what we call a link table design approach. So what's the, some of the very important numbers related to the use case so that you have an idea of what kind of volume or veracity we are talking about. So first of all, this is all real time, and nodes or vertices, right? Talking about we had like around 2 billion, and around relationships between the vertices, which we call edges, right? Around 4 billion, give and take. So write volume TPS 40 million per day means it basically varied from, let's say, 500 per sec when non-peak, and to at highest peak, let's say 5,000 per sec. But that's the write volume, and the query volume it's a mixture of, let's say, mostly we try doing in partition queries and some point reads, but also upserts are there. So it's more of a write heavy, but with also some volume of query volumes as well, where you have some complex queries and a lot of point reads as well. So the point reads was around 250 to 300, let's say TPS per sec, and the number of graph queries per transaction used to vary between 40 to 50. So as you see, right, because it's a link table design approach, 10 years back when the customer kind of built the solution, in fact, I worked with very similar, a couple of other customers as well. They had all used a combination of different, databases which were available to them at that time. So for example, in this particular use case, the link, table, or let's call it the linkage data, was stored in MariaDB. And the node, the edge detail data, it was initially stored in MongoDB. And what kind of traversals are you talking about? So more basic traversals were done again using relational join queries. So basically they were using a mix of primary plus foreign key relationships. And just for folks who are interested in total DB sizes, so we are talking about what, 6 billion database objects here, 2 plus 4. So the 2 billions were around, let's say, 0.5 KB. That's like 1 followed by 9 zeros. That's like 1 TB. And you're talking about the edges being 1 KB per edge object. That's around 4 or 5 TB. So give or take 4.5 or 5 TB of data you're talking about. Just if I move on to what was the query patterns which they were doing, and that's also one of the key reasons why more and more customers we see modernizing using Cosmos, is because it's relational, right? The top query patterns are all relational. So primary ops was a combination of insert update of the node edge rows. Like let's say for a customer, cust A, if I say, so I want to retrieve at a given instant of time, let's say all entities which are linked to the customer. So let's say, how many distinct, let's say, credit cards do you have? How many credit cards, distinct cards did this particular customer use in the last 90 days? How many customers, let's say, shared a credit card with this person? So, you get some information about not just the discrete data points, but also, also ask all sort of questions about this customer vis-a-vis his or credit card. We will limit our conversation there because this was purely to understand the credit card discrete usage. But the key point to note here is it's not just from the customer to his email and so on, but also we want basically the solution required, let's call it architecture pattern, where we could do bi-directional traversal. That was becoming a bit difficult once you are on the relational RDBMS vertical graph solution. And we will take a look at some of the code design patterns as well. We kind of chose. They became very key for scaling this particular solution. Now, if I talk about what kind of, so as I mentioned, the primary was the write operations in MariaDB, which included like insert, update of like node edge rows, but we also had considerable amount of point reads as well. Now, what was the need for modernization? That's like a very important point to understand. Again, without like very basic generalization, because this varies from use case to use case. But in this particular use case, when we got involved with the team, there were fundamentally multiple, challenges. But if I take the top 4, reasons for modernization, the first was handling the complexity of data growth. Now, I want to touch upon this, very important point, that when I say handling the complexity of the data growth, right, we are not meaning that storing, terabytes or petabytes of data, correct? The persistent layer was a challenge. No, that was not the reason. Specifically for use cases, if you are doing fraud detection, fraud analysis, recommendation engines, right? The common pain point that I have seen working with customers over the past 3-4 years, right, very actively, is as your data grows in a relational data store, and the deeper you basically want to kind of dive, storing data is never a core issue. The key challenge gradually becomes not just managing the discrete data points, but let's say a data point here is a record, which let's say in graph we call it a vertex, right? But it also very essential to these use cases is understanding and traversing the relationships between them and between these distinct data points. So this easily fits into what we call discrete data and relational tables. So connected data and managing connected data becomes quite of a challenge. So for example, this customer specifically, when we did not 1x, but 2x, 3x traversals and more, again, not on 20 million, 40 million objects, but exceeding 100 million plus objects. When I say an object, I mean across an edge we are traversing, right? Given, let's say, a 1 KB or a 2 KB limit on our edge, we found that neither the performance, neither latency was good, and also it incurred cost in terms of doing complex querying using standard relational join queries. In other words, not just the traversing bit of it, but if you want to get millisecond level latencies in completing this traversals, it becomes very important to kind of look at optimized graph solutions and move from vertical graph solutions into something which can give you a horizontal scale. Number two, of course, this particular solution built over two RDBMS solutions lacked scalability, and traditional on-premises HA was though part of the solution, but the team needed to kind of scale the server during peak times. There was no SLAs per se in most of the customer use cases I worked. They wanted dedicated SLA on performance if it's available. Definitely on the last mile read latency, write latency, throughput would be excellent to kind of estimate and also optimize for. These two are very, very important points. And then, of course, because of the lack of the above mentioned points, there was a poor TCO for this particular use case. So basically, our recommendation was to use or check out Azure Cosmos DB, for let's call it Azure Cosmos DB Gremlin API. And since 80% of the query traversals basically were using let's say edges, so we basically wanted to kind of understand and also show the customer the value prop of the Gremlin API of Azure Cosmos DB. So let's quickly take a look at some of the key points so that it's clear. So I'll just show you a sample code of something which very much represents the customer use case, but this is not the exact customer code, just for a pointer. So this is in Visual Studio. We're using basically the Gremlin.NET driver. And while we kind of go through the code, we'll also talk about some key design decisions we kind of specifically took a look at. So as you can see, for example, these are standard Gremlin constructs. So when you're adding a vertex, right, you're basically mentioning a label because for us, the Gremlin API, which is an Apache Tinkerpop standard, basically allows you to build what we call property labeled graphs. You had an ID which we assigned to the vertexes, and then you had multiple properties. For example, for this particular use case, we stored the first name, last name, property, when there's this customer on board onto this e-commerce platform, let's assume. When did they use their last credit card? What credit card was it? What was his age? Now, this is a very, very, very important point. That's the partition key choice, possibly the most important design decision for your Cosmos DB, let's say, data model. Now, here I would like to touch upon one important thing. So if you see this, basically, right, this partition key choice, so it's basically a combination of my label and along with the ID. So we kind of tinkered with a couple of use cases. We tested out just using, let's call it unifier or identifier kind of globally, UID. We also created a partition key, a synthetic partition key with a concatenation of both, right? And we also wanted, we also tried checking out using a random, number generator. Now, one important point to note here is, can I replace this, synthetic partition key with a random number, or as a random suffix appended to my UID? You can, but again, the correct answer would be like, it depends, really varies from use case to use case. For example, I worked on a couple of use cases where it was extremely write heavy, but you did not, once you've written or updated a vertex, you never practically read it or, delete it or do any operations. You don't know much of a traversal. In such case, for very good or excellent write latency, it's good to have something which has very high cardinality. But for our given use case, we also had a post-write, of course, an update of vertexes. We also had a considerable amount of point reads. So if you have a unique, let's say a random, prepended suffix or a prefix, right, it becomes very difficult to read a specific item. So that's basically the fundamental reason why we kind of chose a synthetic, partition key. Another important point was a design decision. And again, we tested these out, actually. That's the correct, way of testing it out. Another very important design requirement for this solution, when we were basically discussing, right, was to have, or the ability of where we have different kinds of relationships, but between the same vertexes. For example, in this, I have shown, for example, this particular, let's say, vertex, Subhashish, let's say, knows the second vertex called Abhijit. But it's also possible that, Subhashish knows him because he's working with him. Both are colleagues. So because that's also a fundamental reason when you're trying to study something like analytics, fraud analytics or social media analytics, you want to understand the different types of the relationships between these same vertexes. So that was also a very important design decision that was a bit difficult, when we tried remodeling this with the other, databases on offer. I mean, that's the input that we have received. Then very important was, let's say when we update the vertexes, we counted these are standard, gremlin, operations. Another very important point is how do you limit or optimize for cost and latency? Is basically if you can, restrict or design your queries in such a way that they are in partition queries. So basically, you give the has with a partition key along with and restrict, so you know that that particular query is scoped to the logical partition where the data resides for that given partition key choice. Of course, we had traversals, so we tested out the basic traversals, the traversals for 1x, for 2x. For example, this one specifically is for folks that know customer 1, but also has, also knows customer 2. Then we basically had query patterns like this. For example, we wanted to understand all people older than a certain age and then more, create more complex, relationships between them. Then we basically wanted to understand that all persons were sorted. Then people who this particular customer knows, and people also known by those who this particular customer himself knows. So these are very important in trying to understand if there is a pattern between them in any of the usage of any blocked credit cards or any cards which had blocked APIs to it, or device specific IDs or device UIDs specific to that. One important also point which we leveraged, and we strongly recommend people leveraging, is always to use the execution profile. This is extremely important because it kind of gives you a lot of the parameters for which you can then deep dive into for optimizing queries, specifically from performance perspective, and then eventually moving into latency and then cost. And another very important point is for all of these queries, you have the status attributes. So the status attributes kind of prints out basically, the retry after milliseconds. That's basically, and also the unique identifier for the operation. So we used all of these. And we also used status attributes specifically for getting the what we call total server time and the total request charge. So if I kind of share the output on the screen, like let's say these are add vertexes, but let's say specifically I will go to an operation which is, let's say I'm doing a basic traversal, correct? I would like to know what's the status code. So we have a provide a list of status code, HTTP status codes, and very important for us is to check the total execution time and the request charge, which the RUs utilize for this query. So the recommendation is, and what we did was we tested out on the top 25 queries, and we wrote down specifically for the 1x, 2x, 3x till a certain n level depth, the query patterns, and we tested out also how we could kind of optimize using the execution profile, of course, and decrease the server time, execution time, and also the optimize for the request charge. Can I bring this 10.36 to, let's say, 8 or 5 or 6? This again is a very important, design decision. Now, if I go to the portal, this is what exactly technically it looked like. I mean, of course, for 4 billion, edges, it will be much more complex in nature. And we also utilize a third-party, tool specifically for, visualization of this, let's say graphical representation. But as you see, the most important point, the fundamental reason why we wanted to test out or kind of enable this customer to migrate from a relational, join specific vertical graph to something which is horizontally partitioned, and let's say create complex relationships, was again on the basis of allowing them to store different type of edges and then traverse those edges to do operations on them. And then of course, as patterns emerge, you can feed them down to different downstream applications. And specifically, for example, if I go back to the presentation, I wanted to so basically the troubleshooting aspect of it, definitely the recommendation is used to use the execution profile. which gives you an execution plan, and we use this very actively for optimizing a majority of the queries. Another important point which I wanted to quickly highlight is the design decision choice, which is how do you effectively model for partitioning. I mean, this is a much larger discussion because partitioning, again, is a complex topic, but it's extremely well handled on your behalf by Azure Cosmos DB. So it handles it automatically. Only detail that you need to take care of, which, when you're in the pilot stage or testing it out, is ensuring that you take care of the partition key, which allows you to kind of attain scale. Another thing that we also optimized for was to keep in mind how do you design and optimize in partition versus cross partition queries. That is, there will be cases when you'll be traversing a graph which is connected across two partitions, because technically, though you may say that Cosmos DB provides you unlimited scale, but we have a logical partition limit of 20 GB, right? So it's basically, if you're talking about one object of 1K, so you're basically talking about 20 million graph objects, give and take. So estimating a total data size, again, is something which is very important, which we effectively did. And that is very important because you can then check or test out your level of traversals effectively, where you can restrict. I mean, though in Cosmos, every outgoing edge is co-located with the vertex for you, but how do you optimize and kind of take care of this logical partition limit of 20 GB is something which you should definitely take into consideration. Choosing a partition key, I already covered, something which is high cardinality, but again, which can distribute throughput, storage, and operations for you. Give and take, again, a combination of both of these. And then another very important consideration was cost measuring. Now, for this, we basically used a combination of both, client libraries, as I mentioned, but there are certain practices and patterns which you should be aware of. For example, g.v, that's not a very good query pattern because it's equivalent to a RDBMS table scan, right? Then again, g.v v1, like if you just give the identifier, like it basically fetches a vertex that has a specific ID. Not a very efficient thing because it's not possible to kind of uniquely identify a logical partition by the vertex ID only. So g.v1 has given that primary key. I mean, that is a good way of writing a query, right? So these also, again, are very important things which we took into consideration, right? And we tested out continuously the costs of the top 10, top 20 to 25 queries, including the top 4 levels of traversals. That's a good practice for cost measurement. And then, of course, optimizing it for latency, performance, and cost. Another also best practice which is recommended, which kind of we did, or it's basically to write down your query patterns for your given use case, and then try and estimate and come to an estimate sizing in terms of the total cost. Again, this is a very simplistic or rather oversimplification of our use case. But in real time, for example, as you see, I have given the vertexes, you have taken a sample code, I have tested out using code what's the number of RUs required for execution. Then you basically know for your use case the TPS. Then this is where in the real life you would like to kind of check out TPS for the on-peak versus off-peak periods, because you won't have 10 TPS, let's say, throughout the day, right? You will have times when you will have very low TPS, you will have peaks when it will be 10x or 5x of the TPS. And then you get to an average of adding both the two off-peak plus the on-peak TPS and come to a total RU, right? I mean, we did this very effectively for many of the customer use cases I worked on, and it was very relative to what their sizing was eventually. Of course, give and take some of the operations which were over and not covered in these top 10 or top 20 queries. But once you have an idea of what kind of vertex you're adding, what's the length of the edge, what's the number of properties that you're gonna traverse, usually when you're traversing, then what's the level of updates you're doing. For example, are you just updating the vertex, or is it mostly very little creation of the vertex and the edges which you are mainly updating? Point reads, something which is very efficient. Basically, you're bypassing the query operator, so you're directly going to the endpoint of the physical partition where the data is residing, right? So point reads you can definitely optimize for, but as we saw for our particular use case, let's say we had around 10,000 TPS, and when we scaled it up, let's say on peak is much higher as well. So your design decision of the partition key choice again has to be accordingly decided on that. Then the traversals, very, very key. We basically, for our use case, studied 1x in detail, 2x also in detail, till 3x, not beyond that. Because again, there has to be a very important point which needs to be mentioned here, though we are referring it as a media analytics or a social media engine you're building, or graph analytics, or let's say fraud analytics. But technically, you should leverage, let's say, building OLTP transactions using Azure Cosmos DB Gremlin API. And that's also one of the tips or design decisions, which is the last slide I have, which was some of the key learnings that we optimized for and picked up as we built the use case. That is, we wrote down the key query patterns, we effectively estimate data size, we chose the partition key effectively, we did tweak a couple of pilots, we estimated effectively and early, very important, and then eventually optimized for query latency and cost. And then if there were large volume OLAP workloads, then it's always good to offset that to Spark using the Spark connector, and then basically process it over there. So that's something which technically you should be aware of, and you should be kind of take away from here. So that's the crux of it, in terms of what we did, what we achieved, and of course, given the use case, the total amount of volume of the queries that we have is easily handled. Is also the latencies are optimized for, and at 100 million plus objects for the pilots that we have done, and for some of the use cases that I worked in production as well. The optimization of the queries, if properly done with the choice of the partition key, can result in really highly performant systems for you, which of course you can then leverage other things with downstream applications and other integration of other services on Azure, right? And build a holistic solution. So vertical graph, if you have built or using a link table approach design, definitely do test out Azure Cosmos DB, and it will enable you to build really highly scalable graphs with low latencies and highly performant, and which you can with different tweaks in place, which you can really optimize for getting the best juice out of your solution, let's call it. So that kind of brings me to an end to this particular session.
Great. Thanks so much, Subhashish. This is, I would say, a great example of heterogeneous migration, right? And we know that the job is not fully done even after the migration is completed. So what are the tips and guidance that you've shared with the customer to make sure that this data model and setup is working well down the line? If it needs any optimization going further, maybe once their data size or their workload, the number of requests grow, right? So what were your tips and guidance for that?
Yeah, estimating data size specifically is very key in building a graph solution, because it's not just about storing the vertexes, but one very important thing which we did was to, before concatenating, was to strip down the vertex sizes. Because Cosmos for us is basically it's a property labeled graph, right? So properties play a vital role when you're doing the traversals. So to ensure that you have the most optimized data format is also very key. It's not just about storing. So in RDMS, for example, we see relational, often formats or records have a lot of data in it, which may not be required for a given use case. It's better than to kind of break the use case down into a graph solution versus a bit of it, which maybe the node detail, it's good to still be on a relational database, because the joins are much more simpler. You do not need sub-millisecond latency, and there's no practically, relationship traversal which is required. It's a pinpointed question, right? You can do it within an RDBMS solution or a key value pair. So that was a very important design, discussion. We had lots of it around it. So to ensure, so often we see that people or rather, customers that we work with talk about, like, I have a 5 terabyte data. I would like to bring it to Cosmos DB and do a lot of operations on it. Though it's 100% possible, I would like to mention it, but that may not be the right approach for your given use case always. So to understand the data query patterns is more vital post, or rather, before you design the data model. So we did that very effectively. And also this was discussed that as your data grows, again, the discussion has multiple points. Is it just the data volume growth you're talking about? That is, I will add more vertexes, or will my use case change such that the properties and the number of properties will also grow? Because if I grow them as well and I traverse, my RUs do not remain constant. They will also vary over a period of time. So my total sizing will inflate both in volume, number of vertexes, properties, and also in the total sizing. So then, you have to revisit this data model after 6 months, strip it down, ensure that for your use case, it's highly optimized. Then you will get sub-millisecond latency or very low level latency. So that's something which we, of course, it's open for discussion, and you have downstream applications which feed into this analytics. So you have to ensure also, how do you upload that? And if you have an OLAP kind of a workload where the data sizes are large, again, recommendation is not to use Gremlin. Gremlin should be used only for OLTP. You should then possibly use a Spark connector to offload it to, Spark. So that is, again, a bit of the part of the solution which we are right now, let's say, working on.
Makes sense. Thanks for answering, Subhashish.
Yeah, I think one more question from my side I would ask, like, you covered one of the interesting scenarios on fraud detection. In general, how can we provide a full text search functionality on graph data?
Okay, full text functionality. I am not aware of, but for us, it was like, basically, I did come across this use case, was to feed it into Azure Cognitive Services, and then use the indexing on the query parameters in Azure Cognitive Services, and basically use that indexer to search for the data. But then again, there are certain, I wouldn't call it caveats, but design decisions you need to kind of take into consideration. Like, if your container source data changes, like, how effectively would you re-index or rebuild the index on the Azure search? That basically is part of Azure Cognitive Search, right? We call it. So that definitely is something which we can take a look at.
All right. Yeah, thanks, Subhashish, for joining us. I think it was a great session that we had from you. So thanks once again. I think we have come to the closing time of APAC live stream session. Before we wind up, Sweta, what are your takeaways from the sessions we had today? A few things that you want to highlight from the sessions we had.
Yeah, Saji. So firstly, I'd like to thank all the speakers for taking the time to come today and share their knowledge. If I have to summarize, Saji, in the first half today, we saw some interesting sessions from Heber from Grab, right? He spoke about C3, customer 360 personalization, and especially highlighted how they make the best use of point reads for getting sub-millisecond latency, and how they use autoscale rotating container strategy and apply to their use case for fraud transaction prediction, right? Then we had Brian, who's a startup founder. He highlighted the do's and don'ts for developing quickly with Cosmos DB, focused and walked us through the architecture, how they scale, how they focus completely on their development and not on building infrastructure. So kind of making all the infrastructure and scaling problems irrelevant through infrastructure as code and automation. Then we had Sindhu. She spoke about the important lessons and takeaways on migration of Cassandra from self-hosted to Cosmos DB API, right? Saji, what were your takeaways from the second half of the sessions?
Yeah, I think all the sessions were really awesome, and it was really informative as well. Even I got to learn many things from the sessions we had. If I have to summarize few things from the second half, I think Divakar showed us how to leverage change feed to build a globally distributed real-time application where you can chat among others. So that is one of the greatest example on change feed. And then Rajdeep, who is the Imagine Cup finalist, and he's just 19 years old, who was demonstrating us how to get started with Cosmos DB and how to build a quick full stack applications, and shared some insights on how to get started and the resources that we need to go through if you're getting started on Cosmos DB. And then final session we had from Subhashis. He spoke about one of the interesting scenario on graph solution to migrate the database from migrate the data from MariaDB to Gremlin API, with some of the interesting scenario on fraud analytics, covering some of the important concepts on partition key choice, optimization, and then cost and latency. Overall, we had different topics, which would be definitely useful for the audience we had today, including the data analysts, developers, startups, founders, architects, and also the students, starting from enterprise applications like 360 API to startup applications, where we had a few sessions covering on startup security, fraud detection, and then some of the applications around chat, OSS APIs, integrations, and including search and functions like that. So that's a whole bunch of information and interesting sessions we had today. Sweta, do you want to call up anything before we actually close the segment?
Yes, and this is not all, folks. Apart from these live sessions, we have 17 on-demand sessions for Azure Cosmos DB conference with even more amazing content from our community. So do watch these as well as any of these live sessions that you may have missed out on. You can visit aka.ms/Azure Cosmos DB Conf to catch up with these on-demand and live sessions. You can also join us for our podcast, Azure Cosmos DB Live TV. Our host, Mark Brown, meets with members of the Cosmos DB team regularly, as well as members of the community. You can catch up new episodes or check out the past ones at aka.ms/Cosmos DB Live TV.
Finally, if you are new to Cosmos DB and want to find ways to try out free, read our blog post on the 4 ways you can try Cosmos DB for free, which is available in ak.ms/Cosmos DB-free. We have few more sessions coming up in the EMEA time zone. If you had to catch up our next stream for the EMEA time zone sessions, our next stream will be starting in 3 hours from now, which covers various interesting topics such as change feed, serverless, security on Cosmos DB, and then Gremlin API. I think that's all from us today. We hope all of you have enjoyed the APAC time zone friendly session. Take a break and join us back for the EMEA time zone session. Thank you once again, all the speakers, all the participants, and the wonderful audience and the supporting members. Catch you again soon. Thanks.
Thanks, everyone, for tuning in. Hope you have a wonderful day ahead.